Hey guys, good morning, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing amazing, all of you are doing great. So guys, can you let me know once in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats. Let me know quickly in the chats, people. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Duration of this session will be almost 3 hours. Okay? Duration of this particular session will be almost 3 hours. And I hope all of you are ready with your pen and paper, because I would want you guys to solve the questions with me in the today's session. Right? And it's definitely going to be the rank booster session for all of you. Okay? It is going to revise your entire chemistry as well. This particular session will be revising your entire chemistry as well. Okay? सर पेपर लेवल कैसा होगा वो अब कल ही पता चलेगा. पेपर लेवल कैसा होगा. लेट्स होप फॉर द बेस्ट. आई होप द पेपर नीदर कम्स वेरी इजी नॉर इट कम्स वेरी टफ. It should come in the category of moderate only. It should neither be very easy nor very tough. How long will it take excluding organic? Excluding organic chemistry, it will take 1.5 hours. So should we start? Just tell me once in the chats. I know you guys are anxious right now, worried, but don't think about the consequences, guys. Okay? It's not the time to think what will happen tomorrow, what if this happens, that happens. Avoid those thoughts at this particular point of time. Just avoid those thoughts. Okay? It's going to hamper your preparation at the last moment. So please do not think about what will be the level of the examination, what if paper comes out be difficult, what if I get blank in the examination hall. Do not let space to these thoughts in your mind at this point of time. All right? Rest, stay calm, and make sure this is the last session you are watching. After this, do not go for any academic session. Just close your books after this. That's my personal suggestion to all of you. Okay? Chalo. Let's get going then. Let's get started. My dear students. So, tell me, are you guys ready with the last academic session with me on this particular channel? Are you guys ready? Are you guys ready? Say yes or no. I want the chats to light up. This is going to be the last academic session with me. And my dear students, there is one more session which I've scheduled at 7 p.m. today. That's going to be the tips and tricks session. Okay? Do join that particular session as well. It's going to be a stress buster session for all of you. And I'll not take more than 30 minutes in that particular session, which I've scheduled at 7 p.m. today. Perfect, guys. All right, so let's get going. Let's get started with the first question, my dear students. With the first question, and the question is on your screen. I would want you guys to think over this particular question and let me know its answer in the chats continuously. Let me know the answer of all these questions in the chats. What do you think about this one? Which of the following oxoacids of phosphorus has strong reducing property? Remember all these questions, okay? Just remember all these questions. Questions can be directly, indirectly from these questions only in the actual exam. So tell me, what do you think about this one? Which of the following has got strongest reducing property? I want everyone to give it a try. Let me know quickly in the chats. What do you think? Which of the following has the strongest reducing property? My dear students, it is going to be the H3PO2 Remember this, it is going to be H3PO2 that has got strong reducing property. The first question which was on your screen, and I can see majority has given already the correct answer. That's great. So, moving on to the second question, which is on your screen. What do you think about this one? What do you think about this one? What do you think about this one? Quickly. What do you think about this one, guys? I'm looking at the chats only. I can see majority is coming up with option number 3. So let's get to know whether it's option number 3 or not. First of all, my dear students, if you look at this chromium right here, I would say chromium here is in +3 oxidation state. Now, if you talk about chromium, the outermost configuration of chromium you all must be doing, that's 3d5 right? Now, it is chromium tripositive, so you have to take 3 electrons out. When you take 3 electrons out, 1 from here, 2 from here, it becomes 3d3 configuration, right? So how many unpaired electrons do you see here? I would say there are 3 unpaired electrons. If there are 3 unpaired electrons, how do you calculate the moment, magnetic moment? Under root of n into n plus 2. Under root of n into n plus 2. So it's going to be under root of 3 into 3 plus 2. 3 plus 2 is 5, 5, 3, 15. Under root of 15 will be how much? 3.87. So A, you are matching with option number 2. A, you are matching with option number 2. So it's going to be either 2 or 3. Now the second option is going to decide everything. Nickel. Nickel here will be in +2 oxidation state. So if I ask you, what is the outermost configuration of nickel? Iron, cobalt, nickel. It is 3d8 But my dear students, if you look carefully, it is nickel dipositive. And if it is nickel dipositive, you have to take 2 electrons out. It becomes 3d8 4s0. It becomes 3d8 4s0. And this Cl negative, it's a weak field again. It's not going to cause any sort of pairing, right? So how many unpaired electrons do you see here in 3d8 configuration? In 3d8 configuration, there'll be 2 unpaired electrons, right? So the magnetic moment under root of 2 into 2 plus 2, right? So that means it will come out to be 2.83. So B, you are matching with option number 4. So it has to be option 3. That will be the correct answer of this particular question as well. Okay? Perfect, guys. Moving on to the next question. What do you think about this one? My dear students, there are 3 reactions which are given to you. Their equilibrium constants are K1, K2 and K3. We are supposed to calculate equilibrium constant for this particular reaction. How do we exactly do it? What do you think about this one? Give it a try quickly in the chats. My dear students, first of all, I will have to make this particular reaction. From these 3 reactions. Now, if you look carefully, the reaction which I have to make, in that particular reaction, if you see NH3 is on the left side, but here in the first reaction, NH3 is on the right side. So I'll be reversing the first reaction. When I reverse the reaction, it becomes 2 times NH3 gives N2 plus 3 times H2. And you know, on reversing the reaction, equilibrium constant is inverse, so it's going to be 1 upon K1, right? The reaction which I have to make, in this reaction, your NO is on right side. And here in this reaction, NO is already on right side. So I'm keeping second reaction as such. That is N2 plus O2. It gives 2 times NO, whose equilibrium constant will be K2 only. Perfect. Now the reaction which I have to make, in this reaction, 3 times water is on right side. Here in this particular case, water is already on right side. But do I need water or 3 times water? I need 3 times water. So I'm multiplying this reaction with number 3. It becomes 3 times H2 plus it becomes 3 by 2 times O2 gives 3 times H2O. And you must be knowing, when you multiply a reaction by some number, that number goes to the power of equilibrium constant. So its equilibrium constant will be K3 raised power 3. Now, my dear students, when you add these 3 reactions, you will get this particular reaction, right? And when you add the reactions, equilibrium constants are to be multiplied. So I would say equilibrium constant of this reaction will be 1 upon K1 multiplied by K2 multiplied by K3 raised power 3. Do you see any option like this? K2, K3 raised power 3 divided by K1? Yes, it's option number C. That will be the correct answer of this particular question as well. I believe it's clear again. Okay. These sort of questions you can expect in your NEET examination, people. Question based on characteristics of equilibrium constant. Okay. What do you think about this one? What do you think about this one? MnCN6 trinegative. What would be its hybridization? Quickly. Quickly in the chats. So first of all, if you look at this manganese here is in +3 oxidation state. What is the outermost configuration of manganese? Quickly. It is 3d5. 3d5 4s2. But it is basically your what? It is manganese tri-positive. So you have to take 3 electrons out. You have to take 3 electrons out. Correct? And my dear students, this Cn negative, it's a strong field ligand as well. It's a strong field ligand as well. Perfect. It's a strong field ligand as well. The coordination number here is 6. The coordination number here is 6. So it has to be the octahedral complex. It has to be the octahedral complex. Perfect. Now, strong field ligand causes pairing. Right? So it's going to be directly D2sp3. Okay? It's directly going to be D2sp3. I hope this sort of a question is again clear to every one of you. All right, moving on to the next one. What do you think about this particular question? Quickly, people. The right option for the mass of carbon dioxide produced on heating 20 grams of 20% pure limestone. What is meant by 20 grams of 20% limestone? It means the mass of calcium carbonate, which we have, is 20% of 20. So 20% of 20. Right? How much this will be? It will be 4 grams. So basically, we are going to heat up 4 grams of calcium carbonate. And all of you must be knowing, when calcium carbonate is heated, it gives calcium oxide. And with calcium oxide, what do we get? Carbon dioxide gas. Okay. Now, my dear students, if you look at the question carefully, can I say 100 grams of calcium carbonate, 100 grams of calcium carbonate on heating produces 44 grams of carbon dioxide? Absolutely. If 100 gram calcium carbonate on heating produces 44 grams of carbon dioxide, it means 1 gram calcium carbonate on heating produces 44 divided by 100 grams of carbon dioxide. Now, as far as the question is concerned, how many grams of calcium carbonate am I supposed to heat up? 4 grams. So it means on heating 4 grams of calcium carbonate, the mass of carbon dioxide that is produced is 44 divided by 100 multiplied by 4. The value comes out to be 1.76 grams. So this is the mass of carbon dioxide that will be getting produced on heating 20% of 20 grams of limestone. Right? A simple basic question based on stoichiometry. I believe everyone would have already solved it. Yes? Perfect. Moving on to one more question, people. What do you think about this particular question? ICl, it is interhalogen. ICl is more reactive than I2. Generally, what do you see? Your interhalogens, they are definitely, ICl will be more reactive than I2. What is the reason? What is the reason? Because you know, this ICl bond is weaker than IA bond. ICl bond will be weaker than IA bond, which makes it more reactive basically. So both assertion as well as reason are true. And reason is basically the correct explanation of your assertion as well. Remember this particular point? Okay, this is asked frequently in the examination, this particular question, particularly the JEE examination. So there are high chances that this sort of question will be asked in your NEET examination too. Okay? Perfect. All right. What do you think about this particular question, guys? What do you think about this one? Quickly. The question is from the chapter Chemical Kinetics. Find out the time required for 2/3 completion of the first order reaction. 2/3. So basically, as far as the question is concerned, let's say you have got the reaction A gives B. The reaction follows the first order kinetics. So let's say at time t is equal to 0, the initial amount of reactant was A0. This is 0. Now, as per the question, find out the time required for 2/3 completion. So, what is meant by T 2/3? Time required for 2/3 completion. That means 2/3 of reaction has got completed. That means 2/3 of reactant has got converted into product. If 2/3 of reactant has got converted into product, that means I'll be left with A0 minus 2/3 of A0, which will come out to be A0 by 3. So this is the amount of reactant left when 2/3 reaction would have got completed. And amount of reactant left I represent with AT. Now you can directly use your integrated rate equation. You can say T is equal to 2.303 divided by K. It's going to be log of A naught divided by AT. Now, my dear students, as far as the question is concerned, rate constant K is given to me in the question. It's 4.3 into 10 raised power minus 4. It's going to be log of A naught divided by, what is AT? AT is A naught by 3. So A naught cancels out. This becomes log 3, and log 3 is what? 0.47. Now, it's a matter of calculation, and you can do the calculation and get the time taken to complete 2/3 of the reaction. Okay? Perfect. And when you solve this question till the end, you'll get exact answer as 2.5 into 10 raised per 3 seconds. I hope this also clear to every one of you. Okay, what do you think about this one? The number of radial nodes in 3p orbital. The number of radial nodes in 3p orbital. My dear students, how do we calculate the radial nodes? Let me first of all tell you, radial nodes are also called as the spherical nodes. And how do we get it? It is given by the formula n minus L minus 1. N is your principal quantum number. L is the azimuthal quantum number. Now, in case of 3p, I would say n value is 3. And in case of p subshell, L value is 1. So it's going to be 3 minus 1 minus 1. The value comes out to be 1 here. Okay? So there is one radial node, one spherical node when it comes to your 3p orbital. Perfect? Amazing. Moving on to one more question, guys. What do you think about this particular question? So first of all, the compound that is given to me is XeF6. XeF6. Okay. So first of all, xenon is the central atom here. It has got 8 valence electrons. It has got 6 surrounding atoms, and you should know number of surrounding atoms is equal to number of sigma bonds. Now, my dear students, out of 8 valence electrons, 6 valence electrons have been used to form 6 sigma bonds. So there is 1 electron pair left as such on xenon in the form of a lone pair. So the type of the molecule is going to be AB6L1, and AB6L1 shape is going to be distorted octahedral. It is distorted octahedral. So XeF6 you are going to attach with A only. So it's either going to be A or B, right? Now similarly, the last one is going to be the deciding factor here, XeF4, and I believe XeF4 every one of you would already know. XeF4, the type of this molecule will be AB4L2, right? It's going to be square planar in shape. It's going to be square planar in shape. So this you are going to match with 2. So it has to be option A. That will be the correct answer of this particular question. I can see majority has already come up with A. That's great. Okay. What do you think about this particular question, guys? The radius of second Bohr's orbit. The radius of second Bohr's orbit of He positive. So I'm given with the He positive ion, right? And the radius of second Bohr's orbit. So N1 value is 2. Second Bohr's orbit, they are saying. Its atomic number, helium's atomic number is also 2. And its radius is also given to me as how much? 105.8 picometers. Now we have to calculate the radius of third orbit of Li positive. In case of Li positive, the orbit number that's given to us as 3. Its atomic number, hydrogen, helium, lithium, that is 3. And we have to calculate R2. One result which I believe every one of you would be knowing at this point of time, R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. Correct? So people, R1 is equal to 105.8 divided by R2 you have to calculate N1 ka square. So 2 ka square is 4 divided by N2 square. 3 ka square is 9. Z2 is how much? That is 3. And Z1, that is 2. Do you see one equation that just contains one unknown, that's R2? Just cross multiple and get the value of R2. And as far as I can see, R2 value will come out to be this much, 158.7 picometers. Okay? You just need to remember the formula and you're sorted. You are done. No need to worry a lot about this question as well. Okay. Tell me, guys, what do you think about this one? What do you think about this one? Quickly. Quickly, people. We have to arrange the following on the basis of the magnetic moments. Magnetic moments. So you have to check more than paired electrons. First of all, if you see carefully, what all ligands are here? It is F negative and C2O4 dinegative. F negative is a weak field ligand, and weak field ligand is going to cause it is not going to cause the pairing of electrons. Weak field ligand is not going to cause the pairing of electrons. So which one do you suggest is the correct answer? I've already checked the options. Quick. Quickly. If you look carefully, this is iron tripositive here and cobalt tripositive everywhere. Iron tripositive. Iron has got 3d6. Iron has got 3d6. 3d6 4s2. But this iron tripositive, so it becomes 3d5. Okay, so 5 unpaired electrons. There'll be no pairing. So Fe F6 tri-negative will be have maximum, followed by your CO F6, followed by the other one, right? Because these two are, these are your weak field ligands, F negatives. They do not cause any sort of pairing. Yeah? A simple basic question this is. And I believe everyone would have already solved it. Tell me the answer of this question, guys. The first ionization energy of sodium. Sodium's first ionization energy is given as 496, right? Then you have got magnesium. Magnesium's ionization energy is given to us as 737. Then you have got silicon. Sodium, magnesium, aluminium, and silicon. Silicon has got how much? 786, right? So what do you think is the ionization energy of aluminium here? Quickly. What do you think is the ionization energy of aluminium here? First of all, generally what happens on moving from left to right? This is sodium, magnesium, aluminium, silicon, phosphorus. On moving from left to right, what happens to ionization energy? Ionization energy generally increases. So technically, aluminium should have more ionization energy than that of this. So aluminium should have more, but aluminium has got lesser than that of magnesium. Because in magnesium, you have to take electron out from completely filled configuration, from 3s2 configuration, right? So aluminium's ionization energy will be less than that of magnesium. So which value among all is less than 737? There is only one value that is less than 737, that's 577. So I'll go with option number 3. I'll go with option number 3. I hope you are remembering all of this. I hope you are remembering all of this, people. Okay, the strongest reducing agent. The strongest reducing agent. Reducing agent is the one which undergoes oxidation, right? So you have to check which one will undergo oxidation easily. Oxidation means loss of hydrogen, right? Quickly. Quickly, people. What do you think about this one? Which of the following is the strongest reducing agent? Reducing agent itself undergoes oxidation. So which one will undergo oxidation easily? Oxidation means loss of hydrogen. So which one will lose hydrogen easily? It's going to be BiH3, right? Because of the bigger size of bismuth, right? Lesser bond dissociation energy. So remember, it's BiH3. Okay? It is BiH3 for sure. Chalo, I'm moving on to the next question. I am moving on to the next question, people. These sort of questions are also asked. And yesterday I had posted one video wherein I gave you one direct formula to solve this question. First of all, molality of a 3 molar solution of NaCl. Density is given. Now, you know the direct result between molality and molarity. Molality is equal to 1000 multiplied by molarity divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute, right? Now, my dear students, what do we have to calculate? We have to calculate molality is equal to 1000 multiplied by, what is molarity? Molarity is 3 divided by 1000 multiplied by, what is the density of solution? Density of the solution is 1.25 minus molarity, that is 3, molar mass of solute, that means molar mass of NaCl. Molar mass of NaCl is 58.5. Again, the matter of calculation, do the calculation and get the molality of the solution, right? Thank you, medical student. Thank you so much. I hope this sort of a question you can easily solve by just remembering this particular result and you can easily kill it. And the final answer after solving will be coming out to be 2.79 exactly. Moving on to the next question, people. Okay, the correct increasing order of bond angles. Bond angles. Quick. This question I have showed you many a times. ClF3, T-shaped. Right? ClF3, T-shaped. BF3, trigonal planar, 120 degree. So this will have maximum. So option 1 is the correct answer. Right? Option 1 is the correct answer. Perfect? Okay. Which of the following pair of compounds are isoelectronic and isostructural? What are isostructural ones? Which have got same type. So which one do you think? Which pair is isostructural? Where do you see the same type of the molecules? Where do you see the same type of the molecule? I want to know. My dear students, if you look at the last option, have a look. IBr2 negative. IBr2 negative. Iodine is the central atom, so 7 valence electrons. There is a negative charge as well, so 7 plus 1 makes it 8. Surrounding atoms are 2, that means sigma bonds are 2. So out of 8, 2 are used. 6 are left as such in the form of 3 lone pairs. So the type of the molecule will be AB2L3. Type of the molecule will be AB2L3. Now again you have got XCF2. Xenon is the central atom. How many valence electrons? 8. How many surrounding atoms? 2. Right? Out of 8, 2 are used. So 6 are left as such in the form of 3 lone pairs. So if I ask you about the type of the molecule, it's again AB2L3. So you see these two molecules have got same type. Absolutely. Whenever you see molecules having same type, they are supposed to be what? They're supposed to be isostructural. Okay, so it's option 4. That will be the correct answer of this question. Moving on to the next one. This question has been asked in JEE Mains also last year, right? A simple question this is, and I believe you can easily solve it. So tell me once in the chats, what do you think about this one? What do you think about this one? My dear students, the reaction that's given to us, if I calculate delta Ng for this reaction, delta Ng is the number of moles of gaseous product, which is 1, minus number of moles of gaseous reactant, which is 1 plus 1 by 2. That makes it 3 by 2. The value exactly comes out to be minus 1 by 2. So this is delta Ng. Now you know your Kp is equal to Kc RT raised by delta Ng. Perfect. I can say your Kp divided by Kc will come out to be RT raised by minus 1 by 2. So it's nothing but 1 divided by square root of RT. Do you see any option like this? Yes, option 4. Yes? Perfectly done. Moving on to one more question, guys. Moving on to one more question. The molar conductance of NaCl. The molar conductance of NaCl. The molar conductance of NaCl. HCl. The molar conductance of NaCl, HCl, and CH3COONA. And CH3CONA. These values are given to us. How much these values are? 126, 426, and 91. Right? What do we have to calculate? We have to calculate the molar conductance for CH3COOH. CH3COOH. My dear students, in CH3COH, which all ions do you see? CH3CO negative and H positive. Now, among all these, where do you see CH3CO negative? I'll see CH3CO negative here. Where do you see H positive? I see H positive here. Right? So, I have to calculate lambda naught of CH3COH. So, first of all, it contains CH3CO negative, H positive. CH3CO negative I see here. H positive I see here. So, if this was 1, this was 2, this was 3. So, what I'll be doing? I'll be adding 2 and 3 because it contains CH3CO negative, it contains H positive. So, I'll be adding these two and subtracting first. So, 2 plus 3 minus 1. I'll do this operation. So, 2 plus 3 minus 1, it's 426. Plus 3 is 91 minus 126. Now, solve this and you'll get the answer exactly as 390.71. Okay? A simple question that's in front of you from electrochemistry chapter. What do you think about this one? Arrange the following elements in increasing order of the number of unpaired electrons. Number of unpaired electrons. So, you are given with scandium, titanium, vanadium, chromium, manganese, right? These are given to me. Scandium is 3D14s2, 3D24s2, 3D34s2, 3D54s1, 3D54s2, right? How many unpaired electrons do you see here? Only one in D. 2 unpaired electrons, 3 unpaired electrons, 5 plus 1, 6 unpaired electrons, 5 unpaired electrons. Now you can arrange them on the basis of the unpaired electrons and I believe you can do it easily. Right? Okay. Tell me the answer of this question, guys. It's a simple question, basic question. The correct order of increasing ionic radius. Ionic radii. So first of all of these are isoelectronic species. All of these are isoelectronic species. And by dear students, in case of isoelectronic species, more the negative charge, more the size. In case of isoelectronic species, more the negative charge, more the size. So it has to be option A. That will be directly the answer of this particular question. Okay. Moving on to one more. Look at this one. The pKb of dimethylamine and pKa of acetic acid. Since pKa, pKb values both are given, that means this is a weak base, this is a weak acid. pK is given, pKb is given. That means it's weak acid as well as weak base here, which we have. The correct option for pH. My dear students, how do we calculate pH when we have weak acid and weak base? When we have salt of weak acid and weak base, the pH formula is 7 plus half of, it is P of Ka minus P of Kb. Right? So it will be 7 plus half of. What is P of Ka value? P of Ka value is 4.77. What is P of Kb value? That is 3.27. Right? You can easily solve it and get the pH of the solution. Yes? So when you solve this equation, you'll get the final answer as 7.75. Okay? Perfect. All right. Which of the following molecule is non-polar? My dear students, whenever you have to check non-polar molecules, remember your Ab2L0, Ab3L0, Ab4L0, Ab5L0, Ab6L0, Ab7L0, Ab2L3, Ab4L2. Whenever you see these molecules, remember their net dipole moment is 0 and they are supposed to be non-polar. They are supposed to be non-polar. So we have to check one by one the type of the molecules. We have to check one by one the type of the molecule. Right? If you look at the second option, SbCl5. If you look at the second option, SbCl5. Right? Sb, valence electrons, 5. Surrounding atoms, 5. Right? So lone pairs, 0. Type of the molecule, Ab5L0. And if it is Ab5L0, Ab5L0 comes in this category. So its net dipole moment is 0. It is supposed to be non-polar here. Okay? Remember these types of the molecules. Whenever you see such type of the molecule, they are going to be non-polar at any cost. All right. A simple question which I believe every one of you would be already knowing. I just want to know the answer of this question. What is the reason for anomalous behavior of oxygen? Oxygen shows anomalous behavior in its group. Fluorine shows anomalous behavior in its group. So what do you think? What do you think, people? What do you think? Quickly. The anomalous behavior of oxygen in its group is due to small size and high electronegativity. Right? Similarly, the anomalous behavior of fluorine in its group is again because of small size and high electronegativity. Okay? This sort of a question can be asked. One important element, gadolinium. Gadolinium's electron configuration is important. This has been asked 2 times in JEE examination and it can be asked in your examination too. It is 4F7. 4F7, 5D1, 6S2. Remember it directly. 4F7, 5D1, 6S2. This is the electronic configuration. Exceptional electronic configuration of gadolinium. Remember this particular one, guys. Okay, 4F7, 5D1, 6S2. Tell me, the correct IUPAC name of this K2MnO4. Quickly. Quickly, people, in the chats. I just want to know, what do you think about this one? So first of all, you are going to write potassium. You won't write dipotassium, okay? You just write potassium. Okay? Then it's going to be tetraoxido. Tetraoxido. Potassium, tetraoxido. Tetraoxido. This cannot be. This cannot be potassium tetraoxide. Magnate. Oxidation of manganese, when you calculate here, it will be plus 6. So it is 6. So option 2 is going to be the correct answer of this question directly. No need to think a lot about this one. Okay, no need to think a lot about this one. Is it clear till here? Okay. Just guys, give me a second. Just give me a second. Just give me a second. Just give me a second. Okay, moving on to the next question, guys. Moving on to the next question. The question is from the chapter Chemical Equilibrium. Look at the question carefully, read the question carefully, and give it a try on your own. My dear students, you are given with a reaction that is H2 plus I2. It gives what? It gives 2 times HI. As far as the question is concerned, we are starting with 4.5 moles each of the reactants. Now, at equilibrium, moles of reactant will be 4.5 minus X. This will be also 4.5 minus X, and this will be 2X, right? Because the stoichiometry here is 1, 1, and 2. So 4.5 minus X, 4.5 minus X, this will be 2X. Now, as far as the question is concerned, 3 moles of HI are found at equilibrium. So, number of moles of HI at equilibrium, which as per the question is equal to 3. And as per our calculation, that's equal to 2X. So, I can get the value of X here as 1.5. If you got the value of X, so 4.5 minus 1.5, that is 3, right? This will be also 3. 2 into X, this will be also 3. So I got the moles of each reactant and product in the container at equilibrium, right? Now, my dear students, if I need to write the Kc expression, it will be 3 raised power 2 divided by 3 raised power 1, 3 raised power 1. So it's again 3 raised power 2. The value directly comes out to be 1. So this is the equilibrium constant of this particular reaction. Okay, this is the equilibrium constant of this particular reaction which was given to us. Perfect. All right, moving on to one more question, guys. What do you think about this one? The oxidation state of chromium is in chromyl chloride. Chromyl chloride is your CrO2Cl2. 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 What is the oxidation state of chromium here? Since it's a double bonded oxygen, so chromium gets plus 2 because of this double bond. Again, chromium gets plus 2 because of this double bond. Here it's plus 1, here it's plus 1. So chromium here is showing plus 6 oxidation state, right? So it's plus 6, chromyl chloride. Got it? Again, one simple question. My dear students, a solution is prepared by adding 2 grams of X. So we are given with 2 grams of X. And what do we have? We have got 1 mole water as well. 1 mole water. 1 mole water means 18 grams of water. We have to calculate mass percentage of X. So I would say mass percentage of X will be equal to mass of X divided by total mass of the solution, which is 18 plus 2, that is 20, multiplied by 100, right? So this value comes out to be 10. So 10% is the answer of this question. So mass percentage of X I was supposed to calculate, and we are done. Okay? Perfect. Moving on to the next question, guys. What do you think about this one? The first order reaction has specific reaction rate. Specific reaction rate means rate constant. How much time would it take for 20 grams of the reactant to reduce to 5 grams? The question is like this. A gives B. At time t is equal to 0, the initial amount of reactant that is given to me as 20 grams. Now, as per the question, after what time the amount of reactant left would be 5 grams? After what time the amount of reactant left would be 5 grams? At what time amount of reactant left would be 5 grams? Now, what I'll be doing again I'll be using the integrated rate equation for the first order kinetics. I can say T is equal to 2.303 divided by K. K value is 10 raised power minus 2. It is going to be log of A naught. A naught is 20 and AT value is 5. So this comes out, this goes up, it becomes 230.3. This is 4 log 4 is 0.6. So 230 into 0.6 will approximately come out to be this particular one. 230 into 0.6. It's going to be 138 seconds approximately. Perfect. I believe this sort of equation is again clear to everyone. Okay. All right, people. Look at this particular question. This sort of a question is frequently asked when it comes to the solubility. Okay. Read the question carefully and see how am I going to deal with such kind of a question. My dear students, we have got CaF2. How CaF2 undergoes dissociation? Ca dipositive aqueous, 2 times F negative. Let's say its solubility is S. This will be S. This will be 2 times S because the stoichiometry is 1:2. Now, you have got NaF as well. How NaF dissociates? Na positive plus F negative. What was the concentration of NaF? Concentration of NaF was 0.1 molar. So this would be 0 in the beginning. This would be 0. Now this NaF would have got dissociated completely. So this is 0. This is 0.1 molar. This is 0.1 molar. Now, my dear students, do you see any common ion here? Yes, that's F negative. So concentration of common ion will be 2S plus 0.1. And my dear students, you can just write it as 0.1. Now, this is the process which I'm following. Now, I'll write the KSP expression. KSP expression for CaF2 will be concentration of calcium dipositive, that is S, raised power stoichiometric coefficient 1. Concentration of F negative, that is 0.1, raised power stoichiometric coefficient 2. Well, KSP is given to me as 5.3 into 10 raised power minus 11. Divided by, this becomes 10 raised power minus 2 is equal to S. So S value will be simply 5.3 into 10 raised power minus 9 moles per liter. So it's going to be option 4. That would be the correct answer of this question as well. Okay. Perfect. This sort of a question I've shown you many a times. Read the question carefully and tell me what do you think about this one. My dear students, I'm going to tell you few results related to first order reactions. Do remember them directly because they'll be useful to you. Time taken to complete 75% of the reaction is equal to 2 times the half-life. Time taken to complete 87.5% of the reaction is equal to 3 times the half-life. Time taken to complete 90% of the reaction is equal to 10 by 3 times the half-life. Time taken to complete 99.9% of the reaction is equal to 10 times the half-life. Time taken to complete 99% of the reaction is equal to 2 times time taken to complete 90% of the reaction. Remember these results directly. They are all valid for the first order reactions. Okay? Remember all of them. They're all valid for the first order reactions. Anything can be asked here. Now, as you can see in this question, what do we have to check? Time taken to complete 87.5% of the reaction will be 3 times half-life. So, X value here will be 3. Similarly, anything can be asked out of this. Anything can be asked out of all these. Okay, anything can be asked out of all these. Even this sort of a question I've showed you many a times. Read the question carefully. You have got the hydrocarbon as CXHY and you are doing its combustion. If you are doing its combustion, it will give you carbon dioxide and water. Now, my dear students, when you balance this, it's going to be X plus Y by 4. And this will be X, this will be Y by 2. Now, the question says when a hydrocarbon A undergoes complete combustion, it requires 11 equivalents of oxygen. That means X plus Y divided by 4 is equal to 11. And produces 4 equivalents of water. Produces 4 equivalents of water. So, Y by 2 is equal to 4. So, Y value is coming out to be 8. If Y is 8, so this will be X plus 8 by 4 is 2 is equal to 11. So X value is equal to 9. So X is 9, Y is 8. So it's going to be C9H8. C9H8. Okay. This sort of a question again can be asked in your examination for sure. I'm moving on to the next question, people. Read the question carefully. We are given with the enthalpies of formations. We are given with the enthalpies of formations of all the reactants and products, right? What do we have to calculate? Enthalpy of reaction. Well, you should know one thing, which I believe all of you will be already knowing. Enthalpy of reaction is nothing but, that is enthalpy of formation of products minus enthalpy of formation of reactants. Enthalpy of formation of reactants. Now, enthalpy of reaction is equal to enthalpy of formation of products. So, start with the product. its stoichiometric coefficient is 1 multiplied by enthalpy of formation of carbon dioxide plus the stoichiometric coefficient is 4. It's going to be enthalpy of formation of what? Enthalpy of formation of HCl. So this is the enthalpy of formation of products minus enthalpy of formation of reactants. Enthalpy of formation of reactants. So stoichiometric coefficient is 1. So it's going to be enthalpy of formation of your CCl4 plus 2 times enthalpy of formation of water. Okay. Now all these parameters are given to me in the question. All these values are given to me in the question. You just have to put the values and you'll be getting the enthalpy of the reaction by solving this particular equation. Again, simple and the basic stuff, right? Again, simple and the basic stuff. Perfect. Okay. When you solve this, you'll get the final answer as 173. Look at this question, guys. Even this is the JEE mains asked question and it's a proper NEET standard question and I believe you can do it. What do you think about this one? I want you guys to give it a try once. I want you to give it a try once. Every one of you. Every one of you people. What do you think? What do you think? Everyone. So first of all, as far as the question is concerned, the light has got the wavelength of 400 nanometer. So what is the energy of the incident light? It will be Hc divided by lambda. Hc value will be 1240 electron volt nanometer. Divided by lambda value is given to be in nanometers already. That's 400 nanometer. When you solve this, my dear students, the value comes out to be 3.1 electron volts. This is the incident energy. This is the incident energy. My dear students, for the photoelectric effect to happen, incident energy should be greater or equal to work function. Incident energy should be greater or equal to work function. Incident energy is 3.1 electron volts, right? Work function of lithium is 2.42. So it will show photoelectric effect. Again, incident energy is 3.1, greater than 2.3. 3.1, greater than this. 3.1, not greater than this. So lithium, sodium, potassium, these are the three metals which are going to show the photoelectric effect. All the others won't. All the others won't. Because for the photoelectric effect to happen, incident energy should be greater or equal to work function, right? Then only I can say photoelectric effect is going to happen. I believe, again, this sort of a question, you can easily solve if it comes in the examination. Okay, tell me the answer of this question. Yesterday, I posted one small video wherein I told you these sort of questions are asked. Quickly, guys. Quickly, every one of you. Every one of you. Everyone means everyone. What do you think? It's a pretty simple question, guys. First of all, volume. Volume is the example of extensive property, right? Molar heat capacity is the example of intensive property. Molarity, again, the example of intensive property. E0 is the example of intensive property. Gibbs free energy is the example of extensive property. Molar mass is the example of intensive property, right? Mole is the example of extensive property. Remember these properties directly, right? Anything can be asked out of these. Now you can count how many are extensive and how many are intensive, and eventually you can easily solve this particular question. I believe I'm clear with this. Right? I believe I'm clear with this. One simple question, a confidence booster for you. So tell me the answer of this one. The correct order of metallic character. The correct order of metallic character out of these three elements. Which one would be more metallic? You know, down the group, metallic character increases. Down the group, metallic character increases. On moving from left to right, metallic character decreases. That is the only concept which you'll be using here, and eventually you'll get this answer. Potassium will have maximum metallic character, followed by calcium, followed by beryllium. Okay, because we know down the group, metallic character increases. Left to right, metallic character decreases generally. All right. What do you think about this one? There is an ion whose magnetic moment is equal to. There is an ion whose magnetic moment is equal to 4.9. We have to check the number of unpaired electrons. We have to check the number of unpaired electrons in the metal. What do you think? When can be LHS equal to RHS? My dear students, it's pretty much simple. If n value is equal to 4, this becomes 4 plus 2, 6. 6 4s are 24. Root of 24 will be approximately 4.9. So unpaired electrons must be 4. Simple. Unpaired electrons must be 4. Right? Right, people? All right. Perfect, guys. Chalo, moving on to the next question, guys. Moving on to the next question. Tell me what about this one? It's a simple question. The set which does not have ambidentate ligand. Okay, which does not have, they are saying. Okay, which does not have. It's a pretty simple one. Everyone in the chats. This question at least everyone should solve, guys. I mean, quickly, guys, everyone, let me know in the chats. Exactly. So it's option 1. All right. Chalo, tell me the answer of this one. Exactly. Majority is giving the correct answer. It's option number 1. Good one. Good job. Good job, guys. This again, a simple question, and I believe you can do it. Everyone, thermal stability. These are the hydrides of group 15. Down the group. What happens down the group to the thermal stability of hydrides? This is something which all of you should kill. Absolutely, option 1. Okay. The number of C double bond O. The number of C double bond O in hypochlorous, chlorous, and chloric acid and perchloric acid. Right? You have to talk about the total number of C double bond, Cl double bond O's in all of these. First of all, you should know the structures of all these. Hypochlorous acid, chlorous acid, chloric acid, perchloric. Now we can check the double bonds. Here there is no double bond. 1 double bond, 2, 3, 4, 5, 6. So in total there are 6 double bonds. My dear students, these structures are important. Remember these structures, okay? Remember these structures. Anything can be asked out of these. Anything can be asked out of these. What about this one? What about this one? What about this one? Tell me the answer of this one quick. Quickly in the chats. So first of all, if you talk about your lattice energy is inversely proportional to the size of the ions, right? You know that lesser the size of the ions, more the lattice energy. So more the size of the ions, lesser the lattice energy. So if you look here in this particular case, this I negative, Br negative, Cl negative, F negative. Here the size of ion is maximum. So it will be having lesser lattice energy. Lesser lattice energy means lesser enthalpy of formation. Right? Lesser lattice energy means lesser enthalpy of formation. So it has to be option number 2. That would be the correct answer of the question. Tell me the answer of this one, guys. Tell me the answer of this one quickly. What do you think? What do you think? Again, this is something which everyone should easily solve. So it's going to be potassium. This is going to be trioxalato, right? This will be cobaltate and its oxidation state will be +3. So potassium trioxalato cobalt +3. That's option number 4. That would be the correct answer of this one. The formula for borax is given. OHY, Z times water. You have to give the value of X plus Y plus Z. Borax. First of all, my dear students, if you look at the exact borax is mentioned like this. Remember this formula. Na2B4O5 OH4 8 times water, right? So what is the value of X here? Value of X is 5. What is the value of Y here? Value of Y is 4. What is the value of Z here? Value of Z is 8. So 8, 4 is 12. 12 plus 5 is 17, right? So my point is to remember this formula. Perfect. Question can be framed out of this as well. Question can be framed out of this as well. Yeah? Amazing, guys. Moving on to the next one. Would you be able to solve this one on your own? Just tell me that once in the chats. My dear students, an aqueous solution freezes at this temperature. So delta TF, depression and freezing point, which is basically freezing point of solvent minus freezing point of solution. This is given to me as minus 0.186 degree, right? And you know delta TF is nothing but it is KF multiplied by M. Now, we are given the aqueous solution. Aqueous means solvent is water. And for water, freezing point is 0. So I would say TF, freezing point of solution, is equal to 0.186, right? Which is equal to KF into M. KF is 1.86 multiplied by M. So M value from here you can easily solve. It will be 0.1. You got the molality of the solution. You got the molality of the solution. What do you have to calculate? Elevation and boiling point, delta TB. Delta TB is nothing but KB multiplied by M. KB value is given to me in the question. This is plus here, okay? KB value is given to me in the question, 0.512. Molality is 0.1. The value is 0.0512, right? This is the elevation and boiling point. This is the elevation and boiling point, 0.0512 degrees centigrade. So option 4 is the one. You have to be careful with the options also, people. You need to be careful with the options as well. Okay. What do you think? A simple question this is, and I believe you can easily solve it. You have got the salt AB. Its KSP is given. We have to calculate molarity. Molarity means solubility. Solubility would be equal to KSP. Okay, let me write it completely. So you have got the salt AB, which will undergo dissociation as A positive plus B negative. Let's say its solubility is S. This will be also S. This will be also S. So if you want to write the KSP expression, it will be S square. So S will be equal to root of KSP. Root of KSP means root of 4 into 10 raised power minus 8, which will be 2 into 10 raised power minus 4. Simple. Right? A pretty simple question this is. All right. Which of the following pairs have got same bond order? As you all must be familiar with the fact, isoelectronic species, they have got same bond order. Now, first of all, which one are isoelectronic? Cn negative and CO, they have got same number of electrons, so they are isoelectronic. If they are isoelectronic, their bond order should be same. These are, both of them are 14 electron species. And you must be knowing 14 electron species have got the bond order 3. Right? I believe it's, again, clear to every one of you. Okay, one last question which I'm solving with you. After me, KK sir will be joining in and he'll be solving the rest of the questions. Let me give him a call till then. Let me give him a call till then. Okay, tell me the answer of this question till then. Quick, people. Hello? That was last question, huh? Ah, yes. So, my dear students, they are asking about what? Diborane. Diborane is B2H6. In B2H6, there are 2 banana bonds, if you know. This is B, this is H, this is H, this is B, this is H, this is H, and this one banana bond, this one more banana bond. So, if you look at this particular boron, it is sp3 hybridized. Even this is sp3 hybridized, right? So, they are saying both the boron atoms are sp2 hybridized. So, this is incorrect one. All the others are correct. This bond is called as 3 center 2 electron bond. This also called as 3 center 2 electron. This is correct. The 4 terminal BH bonds are 2 electron. Yes, this is 2 center 2 electron, 2 center 2 electron, 2 center 2 electron, 2 center 2 electron. The 4 terminal hydrogens and the boron are present on the same plane, right? All of this, I believe, is like clear to you. Okay? All of this, I believe, is clear to you. Okay, one last question I'll be solving with you. And after that, your organic chemistry will start. My dear students, if you look at this one, HBr, you are making it to react with what? You are making it to react with BaOH whole twice. Now, first of all, molarity of HBr is given to me as 0.02. Its volume I need to calculate. Molarity of barium hydroxide is given to me as 0.01. Its volume is 10 ml. Perfect. Now, you know, N factor of HBr is 1, so its normality will be 0.02. N factor of BaOH whole twice is 2, so its normality will be 0.02. Molarity into N factor gives me normality. Now you can just use the equation N1V1 has to be equal to N2V2. What is N1? 0.02. V1 is to be calculated. N2 value 0.02. V2 value 10, right? So V1 value will simply come out to be 10 ml, right? So this was the last question, my dear students. Perfect. And I believe it's super clear. Okay, now KK sir will be joining in, right? I'm ending the stream from here and he will start the stream from his end, okay? So enjoy your organic chemistry. I'll see you exactly at 8 p.m. today. Sorry, 7 p.m. Last minute session. I'll take for like 20-25 minutes. Do join that particular session as well. See you guys. Take care. Bye-bye.
Done. Done.
This will be also 3. So I go.
Good morning, everyone. First of all, I wish each one of you all the best for your tomorrow's NEET exam. And stay calm and cool. I'm sure you will be a success. Now, before you write that actual exam, let's do some questions which I believe can be there in your NEET examinations. So, without wasting time, let's begin. But before that, let me know in the chats if I am audible and visible to each of everyone. If I am audible and visible to each and everyone, let me know. Let me know quickly in the chats. Let me know quickly in the chats if I am audible and visible to each and everyone. Okay. Okay. So let's begin. Let's begin without wasting time. First question is, which one of the following pairs is isomer, is an example of metamer? Remember, for metamerism, there must be polyvalent functional group. This is monovalent functional group, so this cannot be a metamer. These are not having, same formula. So this is simply the answer. So A option is the right answer. A option is the right answer. After that, given below are two statements. Statement 1 is hyperconjugation is a permanent effect. Yes, that's correct. After that, hyperconjugation in ethyl cation involves overlapping of C carbon having sp2 hybridization and carbon hydrogen bond. Carbon should be sp2 hybridization and then this one bond with empty. No, carbon should be sp3. That means statement second is incorrect. Statement first is correct. Statement second is incorrect. So statement first is correct. No, this is not the option. Statement first is correct and statement second is incorrect. So statement first is correct, statement second is incorrect. Exactly. After that, among the following compounds, geometrical isomerism is shown by. Geometrical isomerism is shown by this because hindrance is here and this is having this geometrical isomer center is having different groups here and different groups say here as well. So this will show geometrical isomerism. After that, what is the IUPAC name of this compound? Have a look. This is pentanoic acid, and in this pentanoic acid we are having 3-hydroxy and 4-methyl group. So 3-hydroxy 4-methyl, that means it should be like this: 3-hydroxy 4-methyl pentanoic acid. 3-hydroxy 4-methyl pentanoic acid is the right answer. After that, 3-methyl pent-2-ene. Let me write down over here. This is 3-methyl pent-2-ene is this one. This is 3-methyl pent-2-ene. This is 1, 2, 3, 4, 5. So 3-methyl pent-2-ene on reaction with HBr, on treatment with HBr. But in presence of peroxide, we know this is simply an anti-Markovnikov product. So products will be like this: CH3, CH, Br will be attached to this one, and then it is CH, CH3, then it is CH2, then it is CH3. Okay, forms the product, this one. The number of possible stereoisomers, have a look. This is having a chiral center. This is also having a chiral center. That means in this compound, N is equal to 2. And as this compound is what we call a chiral overall, so number of, what we call stereoisomers here is 2 raised to the power N. That means 2 raised power 2. Answer is 4. So its answer is 4. Am I clear till now? Am I clear till now? Because these are very, very, very easy questions. Is this clear? And let me tell you that I will be sharing this PDF on Telegram channel of Unacademy NEET English. Okay, that is clear. After that, you are having a compound like this, the absolute configuration, you have to tell me the absolute configuration of this compound. I hope this is visible to each and every one. This slide is visible to each and every one. Have a look. Have a look. Have a look. This is the chiral center. This is having priority number 1. This center for this chiral center will be priority 2. This will be priority 3. This will be priority 4. That means 1, 2, 3 is clockwise. But as least priority is present on horizontal line, so it becomes S. So this one is S. This one is S. This one is S. After that, this is having priority number 1 for this chiral center, and for this chiral center, this becomes 2 and this becomes 3. So this becomes 4, 1, 2, 3. This is anti-clockwise. Anti-clockwise should be S, but as least priority is present on, I mean to say, horizontal line, so this becomes 4. But when we number this, according to IUPAC nomenclature, so this is 1, this is 2, this is 3, this is 4. So second carbon of this parent chain is S and third carbon is R. That means it is 2S and 3R. So this will be the right option. 2S and 3R will be the right option. Let me know quickly, is this clear? Let me know quickly, is this clear? Let me know quickly, is this clear? Okay, after this, which one of the following conformation of cyclohexane is chiral? Remember, it is Twist-boat. Remember forever, it is Twist-boat. After that, which of the following molecules is expected to rotate plane polarized light? Any molecule can rotate plane polarized light which is optically active. That means, have a look. As this is not having any chiral center, so this cannot be an option. This is having a chiral center. One chiral center in a molecule is optically active. So this is the option. This cannot be an option. This is having chiral centers, but this is having what we call a plane of symmetry over here, as this is the plane of symmetry because this divides molecule into two equal halves such that one half is exactly mirror image of another half. That means this cannot be a chiral overall molecule, not a what we call optically active molecule. Hence, this is optically inactive, optically inactive, optically inactive. This is only molecule which is optically active. Hence, this will rotate plane polarized light. Now, after that, the major product of the following reaction is, you have to do nitration of this. But remember, if you are having already say groups attached to benzene ring, then this nitronium ion electrophile goes to that position. That means the position taken up by this electrophile will be decided by strong ortho-para directing group or strong activating group, and that is this one. So with respect to OH, OH will decide where this NO2 group will go. That means it will go to ortho with respect to OH or para with respect to OH, but as ortho, one of the ortho is blocked. If electrophile goes to this, there will be more steric repulsion. So major product will be, it will prefer to go to para position. That means it will result in the formation of option C. It will result in the formation of option C. After that, the increasing order of reactivity of the following compounds towards aromatic electrophilic substitution reactions. Remember, aromatic electrophilic substitution reaction is directly proportional to electron density of the ring. As we know, it is plus R group. It is a plus R group. Now, this is plus H group. This is what we call plus R as well as minus I, and its minus I is more stronger. This is minus R group. So, this will increase electron density very much. That means, first of all, this will be more electron rich, say benzene ring. Hence, first of all, it will be B, whose rate will be faster. Then C, then after that, it will be this A and then D. So B, C, A, D, it will be this one. First B, then C, then A, then D. That means least reactive will be D. After that, its more reactive will be A. After that, it will be C, and the most reactive will be B. So B, C, A, D will be the option. After that, the increasing order of nucleophilicity among the following nucleophiles is, yes, all these are negatively charged nucleophiles, and we know nucleophilicity decreases as stability increases. Or we can simply say these nucleophiles are negatively charged species. The nucleophile whose conjugate acid is the strongest acid is, say for example, this is having strongest acid, sulfonic acid. Hence, this conjugate base of sulfonic acid is what we call more stable. And if it is more stable, it's a weak base or a weak nucleophile. So the answer will be simply OH minus is stronger nucleophile. That means 4 will be at last. This will be the highest. According to increasing order, it will be this one, 4. And then after that it will be this second one. It will be second one, so there is no option like this. So let me change. This is 4, after that 4, then it will be second. Let me correct this one. Let me correct this. It is 4, after that it is second, after that it is 1, after that it is 1, and lastly it will be 3. So 3 is the least, I mean to say. So it will be like this: 4, then it will be 1, and it will be 3. So this is the right option. This is the right option. This is the right option. Because 3 is the most stable, hence this is least nucleophilic. After that this one, after that it will be 2, and after that it will be 4. I hope this is clear to each and every one. Let me know quickly, is this clear? Let me know quickly, is this clear? After that, we will be having another, the increasing order of pKa. That means, first of all, you have to write down, say strength of acid. So you know this is having minus R group, This is having minus R group. So it increases electron, it increases acidic character. This is having minus I group, it increases electric character. Here, only hydrogens are attached to this, say phenol. So I can say this is neutral, and this is what we call plus R group. So first of all, let me write down B. After that, let me write down C, after that A, after that D. This is what we call strength of acid. This is acidic strength order. But we know acidic strength order is reverse to that of pKa. So I will write down it is D, then A, then C, then B. This will be pKa order, but in decreasing, say this will be the decreasing order, but we have to write down increasing order. So let me write down it like this: B less than C, less than A, less than D. So this is pKa, but in increasing order. This is pKa in increasing order. So B, C, A, D will be the option. That means D will be having, say highest, what we call pKa. Highest pKa means it will be the weakest acid among these. Now, let me know quickly, is this clear till now? Am I clear till now? These are very, very, very important questions, and you will see in tomorrow's paper, directly or indirectly, these questions will be there. Okay, you want me to go slow. As you have very less time, that's why I'm a bit fast. Okay. Now after this, question is, which of the following compounds will form significant amount of meta product? You know this aniline in acidic medium can form anilinium ion and can form meta nitroaniline at that time. That's why this can form what we call meta product during mononitration, but others cannot form meta product. So remember, it is aniline. After that, the order of stability of the following carbocations. First of all, this is resonance stabilized. One is resonance stabilized. This is what we call stabilized because of hyperconjugation or inductive effect. So first we will write resonance, but this is having more resonance. So 3 is more stable than 1. After that, it is 2. So 3, 1, and 2 is the right answer. So 3, 1, and 2 is the right answer. Let me know quickly, is this clear? 3, 1, 1, and 2, not 3, 2, and 1. First, this one, more resonance, then this allyl carbocation because of resonance, and then this one because of hyperconjugation or inductive effect. After that, the electrophile E positive has attacked this benzene ring to generate the intermediate, and these are the intermediate sigma complexes or valence intermediate. Of these, of which of the following, which sigma complex is of lowest energy? Write down. I will be waiting for the response from you. What will be the answer of this question? What will be the answer of this question? Let me know quickly. What will be the answer of this question? Let me know quickly. Let me know quickly. What will be the answer of this question? Okay. Exactly. Now have a look. As this sigma complex means it's an arenium ion, it's a carbocation formed on, this ring, NO2 are electron withdrawing groups, they will destabilize them. Hence, this is the most stable one. C is the most stable carbocation or most stable sigma complex. Hence, this is having lowest energy because lowest energy means most stable. After that, excess of isobutane on reaction with bromine. Excess of isobutane. This is isobutane. This is isobutane. This is isobutane. Now, this on treatment with, excess of this on treatment with bromine in presence of, say for example, what we call heat or light, then gives which of the following as major product? As bromination will take place here, and bromination is a selective reaction. That means form more stable radical. That means tertiary hydrogen will be replaced, and what we will get this product as major product. That means during bromination, remember forever, bromine product or what we call brominated product or monobrominated product will be always formed from more stable carbon free radical. Have a look here, it will form tertiary radical, here it will form primary radical. Which is more stable, primary or tertiary? Tertiary. That's why product will be formed from tertiary, because bromination is a selective reaction. Hence its option is option number D. After that, arrange the following conformational isomers of N-butane in order of their what we call increasing potential energy. Let me first of all correct these two. These two are like this. This is having CH3 over here and this is having H over here. That means this is completely eclipsed. This is partially eclipsed because these CH3 and CH3 groups are like this. Have a look. This CH3, this CH3, and I mean to say this H, they are like this. Let me draw this one like this. This is CH3 and this is H. So this is partially eclipsed form. This is fully eclipsed form. This is, I mean to say, NT form, and this is its gauche or gauche form. And you know, in case of N-butane, in case of N-butane, you know that NT form is more stable. That means first is more stable. After that it is 3. After that it is 4. After that it is 2. So first 4, 3, 2. That means 2 is the least stable form. Fully eclipsed. After that partially. After that partially eclipsed, 2, 4. After that 2, 4. Partially eclipsed, then gauche, then say this one. So first it is NT, then gauche. After that it's partially eclipsed, and finally it is fully eclipsed. Now let me know in the chats, am I clear till now? Exactly 4 is the right answer. God bless you all. No, 3 is the right answer, not 4. 3 is the right answer because first is NT. So NT should be, according to, you have to write down increasing potential energy. Okay. Give me a second. You have to write down increasing potential energy. That means energy, highest energy will be of 2. This is potential energy. Highest energy will be of 2. After that it will be 4. After that it will be 4. Then it will be, say 3. Then it will be 1. It is this one. It is not stability. It's saying increasing potential energy. Correct this one, as it is showing increasing potential energy. It's not showing increasing, stability. Increasing potential energy. This one is having least potential energy because this is most stable. After that 3, after that 4, and after that 2. Exactly, 1 is the right answer. After that, my dear lovely students, given below are two statements. 2-methyl-butane means this one. 2-methyl-butane means this one. This is 2-methyl-butane. On oxidation with KMNO4, gives 2-methyl-butanol. 2-methyl-butanol. Have a look. You know, KMnO4 cannot oxidize, say alkane, unless and until this alkane contains a tertiary hydrogen. As this is a tertiary carbon and hydrogen attached to tertiary hydrogen, it removes this and instead of that OH is there. That means first statement is exactly correct. N alkanes can be easily oxidized to corresponding alcohols. Answer is no with the help of KMnO4. That means statement 1 is correct, but statement 2 is incorrect. Statement 1 is correct, but 2 is incorrect. 1 is correct, but 2 is incorrect. I hope this is clear. I hope this is clear to each and every one. I hope this is clear to each and every one. Exactly, 2 is the right answer. Sir, feeling demotivated, I am thinking to do. Why are you demotivated? So don't worry. You just try to solve these questions. These questions will help you definitely tomorrow. These questions will help you definitely tomorrow because these questions will be asked tomorrow directly or indirectly. It's my promise to you. Okay. Now after that, for the given reaction, the reaction is given, you have to do bromination. And remember, in presence of light, whenever bromination is in presence of light, that means this is free radical substitution, reaction, free radical bromination reaction, and this is benzylic bromination. That means first of all, here will be bromine. That means it will be same this, say benzonitrile, to which this CHBr and CH3 will be attached. That means these should be our meta position. So answer will be B. Answer will be B. Answer will be B. Answer will be B. Exactly. Don't worry at the rate of Nargis. This is very normal. This is very normal. Many of you might be feeling nervous right now. But all you need is to stay calm and cool because you have done your part. You have given everything to this exam to, simply do very well tomorrow, inshallah. So don't worry at all. Don't worry at all. Now, after that, this is a question. This is the question. This is a very important question. Listen carefully because many of students will, do some, what we call, cannot solve this type of question. Have a look. This is actually like this. This is actually like this. Have a look. Let me show you this one slowly. Have a look. What will happen first of all? First of all, there are two double bonds. This HBr is added to this or this one. Add HBr to that double bond which can form more stable carbocation. That means it will be added to this. When it is added to this, Br will be lost and it will result in the formation of a tertiary carbocation. Have a look. This is a very stable carbocation. This carbocation will be formed very fast. Now, after that, there will be resonance. That means another type of carbocation can be like this. Here, it will be a double bond and positive charge will be like this. This will be more stable carbocation. More stable carbocation. Because this is stabilized by resonance as well as hyperconjugation and inductive effect. This is stabilized by resonance only. That means this is less stable carbocation. So which one will be formed easily or which one will be formed very fast? It is this one. So if we form a product from this one, then what will be the product? Product will be like this. Have a look. Product will be like this. And if we form product from this one, what will be the product? Product will be like this. Have a look, my dear lovely students. Both products will be obtained. But this will be obtained very fast because this is formed very fast. So this will be the fast product form. That means this is kinetically controlled product. This is kinetically controlled product. But this will be formed slowly, but this is thermodynamically controlled product. Why? Because this is more stable as compared to this. How, sir? Have a look. This carbon-carbon double bond is having alpha hydrogens 3, 3, 6 and 2, 8. 8 alpha hydrogens are there across carbon-carbon double bond. But here across this carbon-carbon double bond, there is no alpha hydrogen. Have a look. This is alpha position. So 0 alpha hydrogen is there. So this is more stable. Hence this is thermodynamically controlled product. As we know, this can be formed, this can be formed. This can be formed easily. But this is more stable. Hence this is the major product. Hence, this is the major product. Now, I hope this is clear. So major product is this one. Major product is this one. Major product is this one, as this is thermodynamically controlled product. This is kinetically controlled product, but not that much stable as this is. Hence, this is the major product. So here, students generally forms this as the major product. No, its rate of formation will be fast, but major product is this one. Okay, after that, we have another question. Have a look. Am I clear and visible? Am I clear and visible to each and every one? Am I audible and visible to each and every one? Okay. ना पता नहीं क्या फ़ोन को हुआ था, बट आप नए से इसको अमीन से फिर से देख लो, ये फिर से आ जाएगा. ये इंडिया में हर जगह पे था. ओके. Excess is present, sir. What about that? Have a look. If it is present in excess, that means this is present, in excess, that means both carbocations, carbocations can be formed in excess. But remember, you have to tell me that which product will be, major. Major product is always this one, which is more stable product. Okay. After that. Question is, that if this secondary alcohol, have a look, this is your secondary alcohol. This is your question. Question is like this. As we know, this is, tertiary alcohol. This is a tertiary alcohol. This tertiary alcohol on treatment with 20% H3PO4 and after that 358 Kelvin. That means this is dehydration reaction. When this is dehydration, just remove OH, form a carbocation. When carbocation is formed, but there is no rearrangement in this type of carbocation. Hence, what we will say, we will form simply this alkene. So, this is what we call Ra. This is Ra. Now, after that, if same, structure, but little difference is there, it is like this. After that, we will be having tertiary butoxide, potassium tertiary butoxide. That means a bulky base is there. What will happen over here? It is simply E2 reaction. This is alpha, this is beta, this is beta. Both these betas are, same. This is also beta. But this beta is rich with respect to hydrogen. So it can form Hoffman product. This beta is poor with respect to hydrogen. It will form Sadzev product. Generally, Sadzev is the major product. But here, as this is base, is bulky, so it will feel more steric repulsion here as compared to this. That's why it forms here Hoffman product as the major product. So this is the this is Hoffman's product is the major product over here. Now, tell me what is our answer. Our answer is simply, A. Our answer is simply A. Is this clear to each and everyone? Is this clear to each and everyone? A is the right answer. Exactly at the rate of Shoit. Exactly. Okay. After that, this is the question. Very, very, very simple question. You are having this cyclohexene on treatment with something, it forms, this product. So these are basically its allylic positions. That means allylic halogenation has been taken place, and we know allylic chlorination takes place with the help of chlorine in presence of sunlight, or what we call N-chlorosuccinimide, or we can simply say SO2Cl2, that means sulfuryl chloride in presence of heat or light. But here it is chlorine in presence of light, so this will be the option. After that, you will be having a question like this. Here it's a 5-membered ring. To this, it is CH double bond CH2. It is CH double bond CH2. Here it is CH3. This is cyclopentane ring. To this ring, you have to add H3O positive. That means hydration in presence of, I mean to say, acidic medium. So this is the reaction. What will happen? What will happen? Have a look. It is like this. CH3, then it is CH, double bond CH2. On treatment with H3O positive, can I write H3O positive like this? So it will attack this H, water will be lost. So first of all, it will result in the formation of a carbocation like this. It will result in the formation of a carbocation like this. Whenever you are having a carbocation attached to 5-membered ring by means of a what we call single bond, then ring expansion will take place like this. So ring expansion will take place. So it results in the formation of 6-membered ring like this one. So it is CH3, then CH, then this is the bond. Then I mean to say after that it's forming like this. Let me draw over here. Let me draw this one like this. It is this CH3. After that, it's having this one, this one, this one, this one. This bond has been broken and it will result in the formation of a carbocation like this. That means it's a 6-membered ring, or you can write down it's a 6-membered ring in which CH3 groups are there at adjacent positions and one is having a positive charge. Now finally this will lose H and it will form a double bond over here. So what will be the product? What will be the product? Product will be simply this one. CH3 and CH3 present at adjacent positions in a 6-membered ring with, I mean to say, double bond over here. So it will be a 1,2-dimethyl cyclohexene. 1,2-dimethyl cyclohexene will be the product. After that, we will be having another question. Question is very easy. Have a look. Question is that we have X whose ozonolysis, but which ozonolysis? Reductive ozonolysis gives A. We don't know what is X, but A upon treatment with AgNH3 whole 2 and then positive. That means this is a Tollens reagent and it gives B. Now it's saying that B is 3-oxo, then hexane dicarboxylic acid. Okay. That means it will be simply like this. Can I write down like this? It is COOH, B is like this, then it's 1, then it is 2, then 3-oxo, it's 2, then 3-oxo. That means at third position it is C double bond O, then CH2, this is 4, this is 5 and this is 6. So I can simply form, I mean say 3-oxo hexane 1,2-dicarboxylic acid. You can add 1,2-dicarboxylic acid in this question. So 1,2-dicarboxylic acid like this. But this is B. But we know Tollens reagent forms, oxidizes aldehyde only. That means this should be basically aldehyde. This should be aldehyde. Ketone is not affected by, Tollens reagent. That means A should be, as this is B, A should be like this. It is like this. It is like this. It is H, then it is double bond O, then it is CH2, then it is C double bond O, then it is CH2, then it is CH2, then it is C double bond O and then H. So this is 1, 2, 3, 4, 5 and 6. And we know this is A. But before that, this is the product of, what we call ozonolysis. You can remove these two O and you can form a double bond over here. That means 1, 2, 3, 4, 5, 6-membered ring is formed. That means we can form like this. There is a 6-membered ring. Say for example, this is 1, this is 2, this is 3. At 3, we are having double bond. Then this is 4, this is 5 and this is 6. Between 1 and 6, there is double bond. That means there should be double bond and carbon-carbon double bond and carbon double bond oxygen at 1,3 position. At 1,3 position. But here at 1,3 position there should be oxygen. Let me draw like this. Let me draw like this. These are the oxygens. Now this is, if this is 1, 2, 3, 4. No, this cannot be 1, 2, 3, 1, 2. 1, 2, at between 1 and 6, you can write down like that as well. You can form like this between 1 and 6. So alternate. This is not 1, 6. There should be double bond between 1 and 6. That means those two carbons where double bond is present, C double bond O should be present at alternate position. So I can simply say its product is this one. Its product is this one, because here double bond and these, they are present at alternate positions with respect to each other. This is oxygen. First of all, let me write down. So double bond, then CH2, and then double bond O. It's like this. It is this one. It is this one. It is this one. Say for example, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So between 1 and 6 there is double bond, and between 3 there is at 3 there is C double bond O. Is this clear? Let me know quickly. Is this clear? Let me know quickly. Is this clear? Is this clear, my dear lovely students? Is this clear? Okay. Now after that we will be having this one. Is this slide clear? Is this slide clear to each and everyone? Yes, this is clear. Yes, this is clear. Have a look. First of all, you are having acetylene on treatment with lithium amide, that means LiNH2. What will first form? It will remove this acidic hydrogen. NH2 minus will remove this acidic hydrogen. So it will form this one. It will form this one. This on treatment with second. Second is, let me write down over here. Second is this one. It is CH3, then it is CH, then it is Br, then it is CH, then it is CH3, then it is CH3. So this C minus will attack this, Br will be lost. So we will get HC, triple bond C, single bond CH, single bond CH3, then it is single bond CH, single bond CH3, single bond CH3. Have a look, have a look. After that, so this is P. This is P. After that, this is treated with, this is obviously Kocharov's reaction, water in presence of HgSO4, H2SO4. Whenever you are having H2SO4, HgSO4, remember you have to add water. And when you add water, it results in the formation of this one. Across carbon-carbon triple bond, you have to add water. So it will result in the formation of this one. After that, last step in this is, it is NaBH4. That means it will reduce this one. So it will result in the formation of alcohol. So this is R, this is RQ. This is RQ. This is RQ. After that, this Q is treated with H2SO4, concentrated H2SO4, heat. What you have to do is remove this OH with H positive as water. It will form a carbocation over here. But after that, you have to shift this hydrogen to this so that carbocation will be formed over here. When carbocation forms here, 3, 2, 5 and 6 alpha hydrogen, it is stable due to 6 alpha hydrogen. After that, this hydrogen will be shifted to this. That means we will get CH3, CH2, then it will be CH, CH3, then it is C, CH3, CH3 with a positive charge. This is the most stable carbocation in this. So this will become the carbocation. After that, remove this H and form a double bond over here. That means double bond is between carbon and carbon. To one carbon there is 2 methyl groups, and to another there will be 1 CH3 and 1 CH2 CH3. That means carbon-carbon double bond should be there. Yes, carbon-carbon double bond, not carbon-carbon double bond which is having hydrogens, which is having at least 2 methyl on one side and 1 methyl and ethyl on another side. So C is the right answer, my dear lovely students. After that, we will be having another reaction. Reaction is very, very simple. Reaction is like this. You are having CH3CH, CH3. Then it is C triple bond CH. Once again, a Kocharov's reaction is there. That means H2O, you have to add H2O in presence of HgSO4, H2SO4 and heat. What you will do, break this carbon-carbon triple bond and add water according to, Markovnikov's rule. First enol will be formed. After that, you will form simply a carbonyl compound like this. So this will be Rx. This X on treatment with CH3CH2, MgBr, followed by hydrolysis will form. This CH3 will attack this one. So we will get this CH3CH, CH3. Then it will form this one. It will form this one. It will form this one. It will be formed to OH. After that, this is treated with, once again, H2SO4, concentrated H2SO4 and heat. What will happen? Remove OH with this H positive as water. So carbocation will be formed. After that, this carbocation is stabilized by 3, 2, 5 and 1, 6 alpha hydrogens. Shift this hydrogen to this. Now carbocation will be like this. Now this carbocation is the most stable carbocation of this substrate. So this is the carbocation. Finally, you just remove this one and form a double bond over here. Once again, carbon-carbon double bond. To one carbon, there must be 2 methyl groups. To another carbon-carbon double bond, there must be 1 methyl and 1 ethyl group. So carbon-carbon double bond, yes. So A option is the right answer. A is the right answer. Am I clear till now? Am I clear till now, my dear lovely students? Do carefully these reactions, because in these reactions you have to shift, you have to rearrange carbocation. That's very important. You have to rearrange until and unless you can form more stable carbocation. That's why this is the first option is the right answer. After that, this is what we call 1, 2, 3, 4, 5, 6. This is aromatization reaction. This is 2-methyl-hexane. Remember, if it is N-hexane, benzene will be formed. And if it is N-heptane or 2-methyl-hexane, toluene will be obtained. Remember that. Remember that. So toluene will be the major product. After that, the correct sequence of reagent used in the preparation of 4-bromo 2-nitroethyl benzene from benzene. That means we have to check. What? Have a look. We have benzene. From benzene, you have to form this one. You have to form this one. 4-bromo 2-nitro and then ethyl benzene. Now, remember, first you will do its acetylation. CH3, COCl, AlCl3. What will happen? CH3, C double bond O. This will be the electrophile. Attach this electrophile to any of the carbons like this. After that, treat it with zinc mercury amalgam. Zinc amalgam in presence of HCl. That means this is simply, it will convert C double bond O to CH2. So this is simply what we call Clemmensen reduction. So convert this into this. After that, bromination. As we know, this is alkyl group. Alkyl groups are ortho-para directing, but ortho is minor product and para is major product. So write down para, that means major product. Write down major product because you can say simply separate ortho and para. So this is the one of the products, major product. After that, nitration, HNO3 H2SO4. You know, here electrophile is NO2 positive. Electrophile will go to either ortho or para position with respect to more activating group, that means this alkyl. That is why it can go to ortho position or to para position with respect to CH2, CH3. But with respect to CH2, CH3, para is already blocked. That's why it will go to ortho. So this fourth option is the right answer. After that, my dear lovely students, this is very important question. The major product of the following reaction is, remember, first of all, what you have to do is, here it's AlCl3. When AlCl3 reacts with this Cl, it will simply remove this Cl and it will form a carbocation over here. So first carbocation will be formed over here, but here it is hydrogen. This hydride shift will take place. That means this will become CH3 and carbocation will be formed over here. Then this will, undergo intramolecular attack. That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5-membered ring is attached to this, and to that 5-membered 2-methyl groups are attached. That means it is like this. It is like this. This is very simple. This is very simple. No, it's not hard than expected. These are the simple reactions, but I have, arrange such type of reactions in such a way so that your every concept will be revised. These are very easy questions. Don't worry. Now, after that, this is electrolysis. This is Kolb's electrolysis. Remember, whenever you have Kolb's electrolysis, you just remove COOH, COOK or CONA. I mean say just remove, say carboxylic acid group or sodium or potassium salt of carboxylic acid group, form a radical there. When you form a radical here, have a look, it will undergo, say resonance, and it will form another what we call aromatic ring over here. That means we will get naphthalene. We will get naphthalene. After that, benzene on treatment with bromine in presence of iron. That means bromination, that means bromobenzene will be obtained. After that, bromobenzene on treatment with magnesium. Have a look. Bromobenzene on treatment with magnesium. We know magnesium come in between C and what we call halogen. So it will result in the formation of phenyl magnesium bromide, which is basically Grignard's reagent. This is having negative part, this is having positive part. This on treatment with any acidic hydrogen containing compound. We know this is negative part, H is positive. This negative will accept this H. So it will result in the formation of benzene. And another side, will be simply CH3, then OMGBr. CH3OMGBr. So we will get benzene and CH3OMGBr. This is benzene and this is CH3OMGBr. So this will be the product of this reaction. After that, very simple reaction. This is a strong base heating. That means it is simply E2 reaction. This is alpha, this is beta. Form a double bond between alpha and beta. So it will be like this. Remove Cl, form a double bond between alpha and beta. After that, you have to add HBr. Add HBr in such a way so that first of all you just form most stable carbocation. First it will form a carbocation like this. It will result in the formation of a carbocation like this. And this is the most stable carbocation of this reaction. Finally, Br minus will attack to this and we will get a product like this. This will be Br and then this will be the product. This will be the product. Say this one. This is the product of this reaction. After that, whenever you are having HCHO and HCl, remember these will result in the formation of CH2 positive and Cl. So whenever CH2 positive Cl is when this electrophile attacks benzene ring, we will get this one. We will get this. We will get CH2Cl, benzyl chloride. After that, this on treatment with AgCN, we know this is a covalent compound. This N will attack, Cl will lose. That means we will get phenyl. Then it is CH2, then it is NC. That means benzyl isocyanide will be formed. So this is B, benzyl isocyanide, and benzyl chloride is A. So benzyl chloride is A, benzyl isocyanide is B. After that, this is a very important question, and this is from chapter Ether. Have a look. Double bond on treatment with HBr. This is from alkenes. This is from haloalkane. That means first of all, here it will be the double bond. Now, listen carefully. Listen carefully and have a look. First of all, it will form this one. It will form this one. When it is, this HBr is added to carbon-carbon double bond, but this is in excess. It can form this one as well. It can form this one as well. How? Have a look. Whenever ether is treated with HBr, what will happen? What will happen? It will break this bond. Here it will be H, here it will be Br. So we will get simply on one side OH and on another side it is CHBr. OH, CHBr, CH2, CH3. So this will be the product. Another product will be CH3Br here, but that is not given. So from this one, this will be the product. This will be the product. Is this clear? Is this clear? Is this clear? Is this clear? Okay. I will try. Now, have a look. Have a look. This is O and then CH3. This CH3 and OH, whenever you are having ether in such a way that oxygen is directly attached to aromatic ring, one of the products is always phenol. So this will be a phenolic part. That means either this or this. But here, carbocation is more stable over here because of resonance. That's why Br finally goes this. That means it will be this one. After that, Question is, consider the following bromides. Consider the following bromides. Consider these bromides. Now you have to tell me that the correct order of SN1 reaction. You know, rate of SN1 is directly proportional to stability of carbocation. Form carbocation from these. This will be simply, first one will be like this. First one will be like this. This is the carbocation stabilized by 2 alpha hydrogen. This is the carbocation. In second case, carbocation is like this. Stabilized by resonance as well as this is alpha carbon, that means 3 alpha hydrogens. Have a look. This is the carbocation, this is methyl, and this is methyl over here. This is alpha, that means this is stabilized by 5 alpha hydrogens. So second one can form most stable carbocation, hence this will show SN1 very fast. After that it is C, after that it is A, so it is B, C and A. After that, a question is like this, very, very simple question. Here, it is Na positive Cn minus. This carbon is sp3 hybridized, to which this Cl is attached. But this carbon is, say sp2, and you know, here it will be resonance. Due to resonance, this bond becomes very stable. And this bond becomes very stable due to partial double bond character. So it's difficult to break this bond. That's why this will attack this carbon and Cl will be lost. So it remains as it is, but instead of Cl, Cn will be there. Cn will be there. So it will be I, then it will be CH2Cn. So it will be option number D. Option number D. Now what is DDT among the following? Remember, DDT is simply non-biodegradable. Remember this. Among these options, it is non-biodegradable. Other options are not correct for DDT. Dichlorodiphenyl trichloroethane. After that, two compounds A and B with same molecular formula C3H6O. Have a look. Molecular formula is C3H6O. So remember, it's having general formula CnH2n and then O. It can be either aldehyde, it can be either ketone, it can be either, cyclic, it can be cyclic ether, it can be cyclic alcohol. But remember, these are aldehydes and ketones. Now the question is, why they are aldehyde and ketone? How am I sure that they are aldehyde and ketone? Because when such compounds undergo treatment with methyl magnesium bromide to give product C and D, those C and D shows positive tests with ferric ammonium nitrate. Remember, positive test given, ferric ammonium test is positive, and that is shown, this test is shown positive by alcohols. That means C is alcohol, D is alcohol. That means these are aldehyde and ketone. So let's suppose first is this one. First is an aldehyde like this. Let us say first is an aldehyde like this, and second is ketone. It may be either aldehyde or ketone like this. But this on treatment with methyl magnesium bromide means CH3MgBr followed by hydrolysis. Similarly, this one on treatment with methyl magnesium bromide followed by hydrolysis. Listen carefully. They will form an alcohol like this. As this is an aldehyde other than formaldehyde, so it will form a secondary alcohol. And this will form a tertiary alcohol. This will form ketones, form tertiary alcohols on treatment with Grignard's reagent, followed by hydrolysis. Now, Lucas test says that C gives turbidity after 5 minutes. That means this is our C, because secondary alcohol give turbidity after 5 minutes. And D gives turbidity immediately. That means this is D, because tertiary alcohols can form turbidity immediately. After that, iodoform test is positive with respect to C and it is negative with respect to D. Have a look. We know whenever you are having this group in alcohol, that shows iodoform test, that shows haloform reaction. But this is present over here. In this, we are having OH attached to C. To that C, CH3 is attached, but to that C, there is no hydrogen. There must be at least one hydrogen. So this is C and this is D. I hope this is clear to each and every one. So C is this, D and this. So we have to tell that C and D respectively are. So C is this one and D is this one. I hope this is clear to each and every one. After that, we are having a reaction like this. Alkene is given. You have to add B2H6, H2O2, OH. That means you have to add water across this carbon-carbon double bond, but according to anti-Markovnikov's rule, because this is hydroboration oxidation reaction. Now, after that, when you add, I mean to say water across carbon-carbon double bond, but according to anti-Markovnikov's rule, so what will happen? Water, H will be added to this one and OH will be added to this one, because OH, negative part, goes to that carbon-carbon double bond which is having more number of hydrogen, is anti-Markovnikov's addition. So this will be the alcohol first. Now this alcohol on treatment with H2SO4, dilute and heat, what will happen? Remove this one, form a carbocation first. So carbocation will be, stabilized by 3 alpha hydrogens. Now shift this hydride to this one, form a carbocation over here. Then when this hydrogen is shifted to this, it becomes CH2. That means 2 hydrogens from this side, 3 hydrogens from this side, and 1 hydrogen from this side. That means it is stabilized by 6 alpha hydrogens. But finally, when this hydrogen is shifted to this, then what will happen? Carbocation is formed over here. So let me write down final carbocation. Final carbocation is this one. Final carbocation is this one. Let me write down like this. CH3, CH2, this CH becomes CH2, this CH, because hydrogen has been shifted to this, so this becomes CH2. After that, this hydrogen goes to this, it remains CH, and then CH3. This is the most stable carbocation of this. Finally, this will lose this hydrogen and will form a double bond over here. So double bond is present between carbon-carbon, to which 2 methyl is attached on one side, 1 methyl and 1 propyl on another side. Have a look. So this is methyl. This is methyl. These 2 methyls are attached to one of the carbons of carbon-carbon double bond, and to another side it is methyl and CH2, CH3, propyl. So this is our option. So we are having option C. So option C is correct, other options are not correct. After that, the major product of the following reaction is, this is having OH over here, and this 6-membered ring is having double bond O over here. What will happen? First, this PBr3 on treatment with this OH, what will happen? It will replace this OH by Br. So first it will become like this. It will be Br over here, double bond over here. After that, this on treatment with alcoholic potassium hydroxide. Remember, this is simply E2 reaction. Remove this is alpha, and this is, beta. Remove hydrogen from this and this, so it will form a double bond between these two. Now, so double bond is formed between these two. Let me erase this double bond. So that it will become much more easier for you. Now, double bond, because beta is either this or this. Now, remove hydrogen from this beta, so it will form a double bond structure like this. Very, very, very simple. After that, heating 2-chloro-1-phenyl, let me write down over here. 2-chloro-1-phenyl. So this is 1-phenyl. Then it is 2-chloro. This is 2-chloro. Now, 2-chloro-1-phenyl butane. Butane is this one. This on treatment with ETOK, NKOH. That means it is KOH and alcoholic. Now, it is KOH and alcoholic. That means once again it is E2 reaction. Remove alpha from this and remove beta from this, so that double bond and double bond, they are in conjugation. So we will get like this. So we will get a product like this. Now, this is X. Reaction of X with HgOAC. Water. Followed by NaBH4. That means this is oxymercuration, demercuration. Now you have to tell me what is Y. Now add water across carbon-carbon double bond according to Markovnikov's rule. So it is pH, CHOH, and then it is CH2, CH2, CH3. So it will be like this. It is 1-phenyl butan 1-ol. 1-phenyl butan 1-ol. That means pH, CHOH, pH, CHOH, CH2, CH2, CH3. This is the right answer. After that, the most suitable reagent for the conversion of, have a look, primary alcohol to aldehyde, that means mild oxidizing agent. Mild oxidizing agent. This is mild oxidizing agent. This is also mild. This is strong. This is strong oxidizing agent. This is strong oxidizing agent. If this is anhydrous, then this is mild oxidizing agent. But this is also mild oxidizing agent. But remember, pyridinium chlorochromate is most common mild oxidizing agent to convert primary alcohol to aldehyde and secondary alcohol to ketone. So I will write down PCC. After that, we will be having one phenol is like this. On one side, it is bromine in CS2. Bromine in CS2. We know here major product will be, it will be ortho and para bromophenol, but major product will be this one. And on another side, it is CHCl3NaOH followed by acidification, or I mean say this one. So this is known as, we know, Riemann-Tiemann reaction. So B is major product of this reaction is, I mean say, salicylaldehyde. So this is B, this is A. You have to tell me what is A and what is B. Have a look. A is para-bromo, ortho as well as para, but para will be major. So para-bromo, and B will be, I mean to say, what we call salicylaldehyde. Salicylaldehyde. So this is the reaction. After that, this OH cannot be replaced by Cl because here it is resonance taking place, due to which this CO bond becomes strong due to partial double bond character. But this OH, we can replace this OH as it is attached to sp3. We can replace this OH because it is attached to sp3 by Cl. Hence, product will be OH will remain as such, but this OH is replaced by Cl. This OH will be replaced by Cl. So C is the right answer. After that, assertion reason. Synthesis of ethyl phenyl ether. Let me write down. This is phenyl. This is ethyl. Synthesis of ethyl phenyl ether may be achieved by Williamson synthesis. Yes, we can form this one by Williamson synthesis. That's correct. But how to form this one by Williamson synthesis? Have a look. You can form this one by this phenoxide and what we call ethyl halide. This is the right option. Okay, so you can form this. Yes, so assertion is correct. Reaction of bromobenzene. Reaction of bromobenzene. Reaction of bromobenzene. That means this one. With sodium ethoxide. That means this one. Yields ethyl phenyl ether. No, that means you have to attack like this, but this is not possible because bromobenzene, aryl halides do not show this reaction. That means second reason is incorrect, but A is correct, R is incorrect. So A is correct, R is incorrect. After that, we will be having this one. We will be having this one. Have a look. Have a look. It's ether. We know this bond will be broken, and this is SN2 reaction. I will go here, H will go here. Okay, so this will be, I mean say A. A will be this alcohol, CH3CH2, CH3CH2OH. So let me write down alcohol over here. This is CH3, this is CH2, after that this is C, then it is CH3, then it is H, then it is CH2, then it is OH. This is A. But this A on treatment with H2SO4, once again, this OH will be lost in the form of OH2, I mean say in the form of water, carbocation will be formed, then this hydride will be shifted, carbocation will be formed over here. So finally, carbocation will be formed over here after rearrangement. Carbocation will be formed over here after rearrangement. After that, we have to form B. Now, hydrogen will be either lost from this position or from this position, but major product will be lost from this position and we will get major product B like this. So this is the major product of the reaction. CH3CH double bond CH3CH3. I mean to say this one. It is 2-methyl, what we call but2-ene as the major product. After that, okay, you have this one. You have this one. This is very good question. Have a look. Have a look. This is a very good question. Listen carefully. What I am, I mean say how I will be, I mean say solving this question. Listen carefully, listen carefully. when CH3Br, that means when Grignard's reagent is taken in excess, and here it is 2 moles of CH3MgBr. Listen carefully. This is the group where CH3MgBr Grignard reagent can attack. This is the group where it can attack. So first of all, you have to attack on both because you have 2 moles of this and form like this. CH3, this is CH3, then it will become O minus MgBr with a positive charge, then CH3 will be here. And this will be C double bond N minus MgBr with a positive charge on this and CH3. First 2 moles will do this one. But after that, when you do hydrolysis of this O minus MgBr will be changed to OH. So it will result in the formation of this one. It will result in the formation of OH and CH3 is there. And this one will be simply OH, that means it will form C double bond O and CH3. So this will be, formed when treated with 2 moles of CH3MgBr followed by hydrolysis. It's not like that. First you will form alcohol, then you will attack with Grignard's reagent. That is incorrect. First attack by Grignard reagent with this to this, and after that hydrolysis of both result in the formation of this. Now this on treatment with once again H2SO4 heat, what will happen? Remove OH, form a carbocation. When carbocation is formed over here, hydrogen will be transferred to this. Finally, it will result in the formation of a carbocation like this. It will result in the formation of a carbocation like this. It will result in the formation of a carbocation here. Resonance stabilized as well as stabilized by hyperconjugation, and this is COCH3. Finally, my dear students, this here it will be H, which has been shifted from this position, this to this. So this H will be lost and it will be a double bond over here. It will be a double bond over there. So product will be simply like this. CH3CO on one side of this ring, then double bond and this benzene ring, they are in conjugation, and then CH3, 3 CH3s are present at consecutive positions. After that, you have to match one is basically item 1 is the starting material, item 2 is the reagent for preparation of benzaldehyde, Now have a look. This one is benzene on treatment with COHCl AlCl3, we call that reaction as Gattermann-Koch reaction. We can form benzaldehyde, that means 1R. So 1 is what we call R. 1R means either C or what we call D. After that, benzonitrile means this one. First you have to simply what we call, this is simply reduction. Now reduce this, it will result in the formation of amine. It will result in the formation of primary amine. But here it's not reduction by H2, it is reduction by using SnCl to HCl. That means it is Stephan reduction. Yes, we know benzonitrile on treatment with what we call SnCl to HCl, that means Stephan reduction. First forms imine, followed by hydrolysis gives benzaldehyde. That means 2 is Q. So first is R, 2 is Q. First R, 2 Q. That means it is option number D. After that, benzoyl chloride gives benzaldehyde by a reaction known as Rosenmund reduction. That means reduction by using Rosenmund's catalyst. So it is this one. So 1 is R, 2 is Q, and 3 is P. After that, we will be having some A, which results in the formation of this one. So what is A? Very, very simple. A should be this cyclohexane. Have a look. Why cyclohexane? Why not others? Have a look. When it is cyclohexane, upon bromination in presence of light, any one of the hydrogens will be replaced by bromine. So it will form bromocyclohexane first. After that, second reagent is alcoholic potassium hydroxide. Alcoholic potassium hydroxide is there. So remember, it is E2 reaction. So remove halogen and hydrogen from its adjacent position. So it will result in the formation of cyclohexene. Now this cyclohexene on treatment with O3, but followed by CH3 whole 2S. Remember, whenever it is dimethyl sulfide or zinc water, it is always reductive ozonolysis. Now, you can break this one, give double bond O to this, double bond O to this. That means it is simply CHO. One of the groups is CHO, then it is CH2, then it's another CH2. So 1, 2, 3, 4 CH2s are there. So third CH2, then fourth CH2, and then this is once again C double bond OH. That means this on treatment with now NaOH, aqueous and heat. That means this is simply what we call aldol condensation, but intramolecular aldol condensation. For that, let us suppose this is alpha hydrogen. Just remove two hydrogens from alpha position and double bond O from this position, form a double bond between alpha and, I mean to say, this carbonyl carbon. That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5-membered ring is formed. 5-membered ring is formed. And to that 5-membered ring, CHO group is attached. And that carbon to which CHO group is attached form a double bond there. That means alpha beta unsaturated aldehyde is obtained. Alpha beta unsaturated. Sorry. This is alpha, this is beta. Alpha beta unsaturated aldehyde is obtained. Similar type of aldehyde is obtained. That clearly indicates it is cyclohexane. Or you can go backwards like this. You can do simply retroaldol like this. Give 2 hydrogen to this, give oxygen to this. You will get this one. But you know, this is the product. That means alkene from which this has been obtained. Remove this double bond O, form a double bond. That means it is cyclohexene. But if it is cyclohexene, remember, that means before that it is E2. Give one of the carbons hydrogen and another halogen. That means it will be like this. And if it is formed, obviously it has been formed from this one, not from this, not from this, not from this. That is why you can do, say reverse reaction, so that you will get A as the right option. After that, it is RCN. It is RCN, means this is the cyanide which on treatment with ALH and then isobutyl. That means this is dibyl H. This is dibyl H basically, followed by hydrolysis. We know cyanide upon treatment with dibyl H followed by hydrolysis forms aldehyde. That means it is simply this one. Convert CN to CHO group. After that, toluene on treatment with what we call KMNO4. Very, very simple. Toluene on treatment with KMNO4, that means a strong oxidizing agent. We know it will result in the formation of a benzoic acid. It will form benzoic acid. This benzoic acid, it is A. On treatment with SOCl2, this is A. Simply replace this OH by Cl. It will form benzoyl chloride. So this is B. This benzoyl chloride on treatment with H2PD, BaSO4, that means Rosenmund reduction. Remove this Cl by H, you will get simply benzaldehyde. That means C6H5CHO is the right answer. After that, reaction is here, and reaction is like this. Reaction is like this. Br2KOH, or it can be Br2NaOH, or it can be X2NaOH, or it can be NaOX, it can be KOBr, it can be NaOBr. In nutshell, this is haloform reaction. During haloform reaction, what we have to do is break this one, convert this CH3 into, say CHX3, but X as here is bromine, so it will form CHBr3. And give ONA, OK, depending upon the base, so give OK. Negative part, positive part, and O minus to this one, this acid. So it will result in this C double bond O. So it will result in the formation of COOK, and then it is CHBr. COOK and CHBr. So one is A, another is B. So it is option number 1. Potassium salt of benzoic acid and bromoform will be the product. After that, statement 1, nucleophilic addition of sodium hydrogen sulfite to an aldehyde or a ketone involves proton transfer to form a stable anion. Yes, that is true. nucleophilic addition. We have done those reactions. Now, after that, statement 1 is correct. The nucleophilic addition of hydrogen cyanide to an aldehyde or a ketone yields amine. No, that's incorrect because they result in the formation of cyanohydrin. So, statement 1 is, exactly true, but statement 2 is false. Statement 2 is false. Statement 1 is correct. Statement 1 is correct, but statement 2 is false. After that, the very simple reaction. Have a look. Transformation from this to this. If you use H2Ni, then this C double bond O should be changed to COH, but it's not that. NaBH4 will convert this double bond O to CHOH, but this is C double bond O, change it to CH2, so it is simply either HI in presence of red phosphorus, simple reaction, but or you can convert C double bond O to CH2 by Clemmensen reduction or by Wolff-Kishner reduction, but here it is NH2NH2OH minus, that means it is what we call Wolff-Kishner reduction. That will not reduce these double bonds, so this is the better, reagent among these. So convert this to this, is best reagent is NH2NH2, hydrazine in presence of basic medium, Wolff-Kishner reduction. Now have a look. You will be having this one. You will be having this one. You will be having CHO. That means this is an aldehyde. Have a look, but without acidic hydrogen or without alpha hydrogen. This on treatment with HCHO. Once again an aldehyde without alpha hydrogen. As these two are different aldehydes, they will undergo cross Cannizzaro reaction. One aldehyde is oxidized, another is reduced. But this is most reactive towards nucleophilic addition reaction. This is oxidized and this is reduced. That means it will result in the formation of this one. It will result in the formation of this one, OCH3. Then here it will be CH2OH. And this will be oxidized to sodium salt of carboxylic acid. After that. Now, CH3, CH2, okay, you have to write down only one. So let us suppose this is A. Let me erase this one. Now, after that, because these are, ring structures, so let me say this is A. After that, this is treated with CH3, CH2, Br in presence of NaH and solvent is DMF, dimethyl formamide. This soda, NaH, sodium hydride, this will take simply this hydrogen and it will form O minus. That O minus will attack this carbon and Br will be lost. That means it will result in the formation of this. It is CH2. Then it is O. O is forming a bond with the CH2, then CH3. That means that ether will be formed over here. This on treatment with HI and heat. HI and heat. What will happen? Break this bond, simply this bond. Because it can form a very stable carbocation, give I to this, H to this. Then break this bond, give H to this and I to this. That means it will form CH3I. Then it will be phenolic group, then it will be CH2I. This CH3, CH2OH on treatment with HI further gets changed to CH3, CH2I. So the final products will be CH3, CH2I, CH3I and this one, in which benzene ring is attached to OH on one side, CH2I on another side. Have a look. OH on one side and CH2I on another side. That means C is the right answer. After that, we will be having another question. Aldehyde plus alcohol gives acetal in presence of, this. This is nucleophilic addition reaction. We know that. And nucleophilic addition reactions will be very much fast if electrophile is a better electrophile and nucleophile is a better nucleophile. So you have to check which among these is a better electrophile. HCHO is the best electrophile, so it will show much more faster reaction. But HCHO is here and here, but this is tertiary butyl alcohol, this is methyl alcohol, this is lesser nucleophilicity as compared to this because of steric hindrance. So that's why this reaction will be very much fast when aldehyde is HCHO and alcohol is methanol. After that, silver mirror test is given by, we know this is given by either aldehydes or alpha hydroxy ketone, remember, or hemiacetals or formic acid, or we can simply say what we call N-phenyl hydroxylamine or terminal alkynes. But here, this is ketone, but this is aldehyde. Ketones do not show this reaction, hence this will be shown by formaldehyde, that means an aldehyde. After that, the increasing order of rate of HCN addition to compound A to do D is, we know first it is aldehyde, so I will write down A first. After that, it will be ketone, but among ketones, first of all, it is B, then it is, I mean to say C, then it is D, because nucleophilic rate of nucleophilic addition is directly proportional to the positive charge or magnitude of positive charge present on carbon of C double bond O, or it is directly inversely proportional to steric hindrance. More the steric hindrance, lesser will be the rate. So it is A, B, C, D, but this is decreasing order. Increasing order, we can say D, C, B and A. 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 So third is the right answer. So it is first D, which will be least reactive. After that, it is C, a little more reactive than D, then B is more reactive than C, but A is the most reactive among these towards nucleophilic addition reaction. Now match list 1 with list 2. List 1 is chemical reaction and list 2 is reagent. You have to match 1 and 2. CH3COO CH2 CH3 gives, I mean say ester gives, I mean say ethanol. Ester gives ethanol. It is simply what we call hydrolysis. It is simply hydrolysis in acidic medium. Okay. Now, this is CH3COOCH3, that means ester resulting in the formation of aldehyde. So, ester forms aldehyde by using diable H, that means A2B3. After that, A2B3, that means it is simply option number 1. Have a look. It's cyanide. Cyanide gives aldehyde by using Stephen's reduction. That means C is 4. Then it's cyanide to ketone by using Grignard's reagent. So it is A2, B3, C4 and D1. After that, it's acetic acid on treatment with SOCl2. Just replace this by Cl. So we will get CH3COCl. This on treatment with benzene, on treatment with benzene, it will form C double bond O and then CH3. This on treatment with KCN in presence of, I mean say OH minus. This is actually, let me write down over here, HCN in presence of OH minus. Then cyanohydrin will be formed. Cyanohydrin will be formed, CN and OH. That means it will be like this. This is simple nucleophilic addition reaction and our product will be like this. It will be OH, it will be CH3 and it will be CN. So on addition of HCN in basic medium, it will simply form cyanohydrin. It will simply form cyanohydrin. That means to benzene, carbon must contain CH3, CN and OH. That means it is option number C. After that, my dear lovely students, this is very, very, very simple. This is the amine structure with the help of which most of the students feel that, oh, this is very much difficult. No, this is an ester. This is C double bond OH. Just break this ester bond and give hydrogen to this, give hydrogen to this. That means ester group is converted to aldehyde and this gives, I mean say H. This is basically this reaction. Whenever you are having an ester, convert this part into aldehyde and give this H and it will form alcohol as well. So it is very, 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 very simple. So it is simply this one. It is simply this one. It is simply this one, diable H. After that, okay, on treatment with alkaline KMNO4 followed by hydrolysis. So this part, irrespective of how many carbons it contains, it will simply form benzoic acid. So it will form benzoic acid. Okay, after this, phenol, parachlorophenol. It's like this, parachlorophenol. Have a look. It is parachlorophenol. On treatment with chloroform, aqueous NaOH. That means, first of all, this is simply what we call a reaction known as Reimer-Therman reaction. So here dichlorocarbene will be attached to ortho or para position, but para position of phenol is, I mean to say, blocked. So it will result in the formation of this one. It will result in the formation of this one. It is ONA, then it is CHCl2. This is Cl over here. After that, as this is treated with aqueous NaOH as well, so those NaOH molecules will replace this Cl by 2OH, and finally it will result in the formation of this one, ONA, and then this is CHO, and this is Cl. After that, this on treatment with HCHO. in presence of once again NaOH, concentrated. That means this is once again an cross, I mean to say, Cannizzaro reaction. Now cross Cannizzaro reaction, this will be oxidized to HCONa, and this will be reduced. This will be reduced to like this. This will be reduced to like this. It will form CH2OH and Cl. Now finally, this on treatment with acid, that will form formic acid, methanoic acid, that means HCOH, and this will form this one. This will form this one. This will form this one. OH and then CH2OH and then Cl. CH2OH Cl. OH CH2OH Cl. Have a look. It's option number. Okay, this is formic acid. Yes, then it is option number this one. Option number D. Here OH, here it is Cl, here it is CH2OH. After that, this is the reaction. You have to do nitration. That means you have to add NO2 positive. But remember, this is C double bond O means electron withdrawing group. This is NH means electron donating group. It will increase electron density of this ring. That means to this ortho and para position, NO2 positive will be attached or nitro group will be introduced. But ortho will be minor product, major product will be para, hence it will be this one. So para with respect to NH. After that, you have to tell me the acidic character order. Acidic character order. Simply, first of all, it will be 1, which is acidic because of NO2 group. After that, all are carboxylic acids. After that, it will be simply what we call 4. After that, it will be 2. After that, it will be 3. But this is decreasing order. Increasing order will be 3, 2, 4, and 1. 3, 2, 4, and 1. 3, 2, 4, and 1. That means this one. So 1 is the most acidic. After that, it is 4. After that, it is 2. And 3 is least acidic because of electron donating OH group. Boval-Blanc reduction involves reduction of an ester in presence of sodium alcohol. Remember this. Reduction of ester in presence of sodium alcohol is known as Boval-Blanc reduction. In presence of small amount of phosphorus, aliphatic carboxylic acids react with chlorine or bromine to yield a compound in which alpha hydrogen has been replaced by halogen. That means alpha halogenation by using chlorine or bromine in presence of what we call red phosphorus or small amount of phosphorus is known as HVZ reaction. That means Hell-Wohlhard-Zelensky or Zelensky reaction. Now, this reaction. First of all, CH3COOH is treated with lithium aluminium hydride. That means it is first formed to CH3CH2OH. Alcohol. This alcohol on treatment with PCl5. Remove this by Cl, it will result in the formation of CH3CH2Cl. After that, it's treated with alcoholic potassium hydroxide. That means we will get ethene or ethylene. So, fourth is the right answer. After that, this aniline on treatment with strong oxidizing agents in acidic medium, for example, K2Cr2O7H2SO4 or Na2Cr2O7H2SO4, remember it results in the formation of benzoquinone like that of phenol. After that, this on treatment, I mean to say reaction is like this. Have a look. It is Br over here, and then it is C double bond O and then NH2. This on treatment with KOBr means this is Hoffman bromamide degradation reaction. So it will simply result in the formation of this one. 3-bromo meta-bromo aniline or 3-bromo aniline. After that, similarly, this on treatment with lithium aluminium hydride followed by hydrolysis. Both will form amines. From amides, but the difference is, in first there will be one carbon lesser than that of parent, amide, but in second, number of carbon remains same. It is only this C double bond O which has been changed to CH2. That means Ra is aniline and Rb is 3 3-bromo. This is, sorry, 3-bromo aniline, and second is 3-bromo, what we call benzylamine. It's like this. It is like this. It's option number this one. After that, aniline on treatment with HNO3 H2SO4 gives para-nitroaniline. This is correct. Which of the following reactions does not occur? This can occur. Okay, this is Friedel-Crafts alkylation of aniline. It does not occur, so this will be our, option. This is acetylation. This can occur. This is, sulfonation. This can occur. So this cannot occur. Remember, Friedel-Crafts alkylation and Friedel-Crafts acylation. This is not shown by aniline. Remember. After that, Gabriel thalamide synthesis cannot be used to prepare aromatic primary amine. Exactly correct. Because we cannot prepare aromatic primary amine from Gabriel thalamide reaction. Reason, aryl halides, because aryl halides do not undergo nucleophilic substitution. This is substitution. Cannot undergo substitution. Cannot undergo substitution reaction. Exactly, both are correct. And second is the correct explanation. Exactly. So both assertion and reason are true, and reason is the correct explanation of assertion. Exactly. After that. This on treatment with this one, that means, have a look. Let us suppose this is R and X, and this is N minus having potassium. This is potassium thalamide. We know this R will come to this. So R will come to this. If suppose R is this one, that means it should be NCH2PH, C double bond O, then NCH2PH. Then this will be broken, So it will become simply PH, CH2NH2. That means benzyl amine will be the product. So this will be the product. Why? Because we know this is very, very simple reaction. We know this in this fashion. Have a look. Gabriel thalamide reaction. This is the Gabriel thalamide reaction. Have a look. This is the Gabriel thalamide reaction. When it is treated with RX, it will first result in the formation of this one. After that, after hydrolysis, whether it is acidic hydrolysis, basic hydrolysis, this will be broken. Give hydrogen to this. So we will get primary amine. Now, let us suppose the value of R here is pH and CH2. If value of R is pH CH2, so it is pH CH2 NH2. So pH CH2 NH2, it is this one. After that, primary, secondary and tertiary amines can be separated using acetylamine, chloroform. No, these can be separated from each other by using, Hinsberg's reagent. And Hinsberg's reagent is benzene sulfonyl chloride. But nowadays, benzene sulfonyl chloride is replaced by paratoluene sulfonyl chloride or paratosyl chloride. So fourth option is the right answer. After that, aniline on nitration gives ortho, nitro and para product. Yes, we know that. Now, what is the question? Question is, among these ortho, meta and para products, which one is major? Whether it is A, whether it is B, whether it is C. We know para product is formed 51% in this reaction. Remember, meta is formed 47% and this is formed only 2%. So what will be the answer? It will be C, B and A. That means first para, then meta, then ortho. So C, B and A. After that, carbyl amine test is used to detect presence of primary amino group in an organic compound. Which of the following compounds is formed during this test? During carbyl amine test, we know bad smell is, bad smell will be, there, and that bad smell is due to isocyanide. So we will simply say isocyanide or carbyl amine or isonitrile will be formed. After that, nitrobenzene on treatment with SnCl2. Have a look. Nitrobenzene, C6H5NO2 on treatment with SnHCl means on treatment with reducing agent, they will simply form aniline. Now this aniline on treatment with, C6H5, then N2Cl having a negative charge, that means benzene diazonium chloride in acidic medium, results in the formation of a product P. But remember, this P is yellow colored. This P is yellow colored compound. This P is a yellow colored compound. And we know this is a coupling reaction, and yellow colored compound formed is like this. Yellow color compound formed is like this. It is this aniline to which this diazo group is attached at para position. This is simply electrophilic substitution reaction. So this is 4-amino azobenzene. 4-amino azobenzene. This is what we call a yellow colored dye, or we can say this is yellow dye. Okay, so you have to tell what is P. That P is 4-amino azobenzene. That means it is first option. It is first option, simple. After that, aniline on treatment with NaNO2HCl, we know this is diazotization. Aniline on treatment with what? On treatment with NaNO2HCl, it is simply a diazotization reaction, 0 to 5 degrees Celsius or 273 to 278 Kelvin. It will first result in the formation of diazonium salt. Now this diazonium salt finally gives phenol. Now you have to choose what will be A over here. You have to tell me A. You know, whenever benzene diazonium salt is heated with water, it will result in the formation of phenol. Now have a look. Have a look. This is our X. This is X. So what is X and what is A? Have a look. X is benzene diazonium chloride. X is benzene diazonium chloride. Now X is benzene diazonium chloride, but A is water and heat. That means it is option number D. Option number D. After that, match list 1 with list 2. Acyl chloride to aldehyde. Reaction is known as what we call Rosenmund reduction. That means A is 2. A is 2. After that, A is 2. It is acid having at least one alpha hydrogen to alpha chlorocarboxylic acid. This is chlorination taking place in presence of red phosphorus followed by hydrolysis. That means HVZ reaction. That means A is 2, B is 4. A is 2, B is 4. That means it is option number, this one, sorry. So it is option, I mean to say third, option third. After that, you can check out that amide to amine with lesser number of hydrogens, lesser number of carbon, sorry. The one carbon is lesser in primary amine. That means it is Hoffman bromamide reaction. That means C is, I mean to say 1. After that, ketone to, I mean say hydrocarbon. That means this is simply what we call a reduction. And this reduction here is Clemmensen reduction. That means D here is 3. D here is 3. So it is A2, B4, C1 and D3. After that, this will be the last question, my dear lovely students. Now, have a look. This is nitrobenzene. You have to convert nitrobenzene to what we call 1,3-dibromobenzene. This is very, very, very simple conversion. Have a look. Whenever you are having nitrobenzene, if you treat it with bromine, what will happen? Br positive will go to meta position with respect to nitro group. So it will go to meta position with respect to nitro group. So it will be like this. After that, you have to simply reduce this NO2 by using reducing agent like SnHCl. You have to choose among these. So that is why it will result in the formation of NH2 and then Br is over here. Finally, what you have to do is diazotization reaction, NaNO2HCl at 0 to 5 degrees Celsius. What will happen? This NH2 will be replaced and diazonium salt will be formed like this. Now finally, treat it with CuBr-HBr. What is this reaction known as? Sandmeyer reaction. So you will get 1,3-dibromobenzene. That means here option number 2 is the right answer. Option number 2 is the right answer. So these were few 80 questions. These were few 80 questions which we have completed in this session, and I am pretty much sure that tomorrow in your paper questions will be around these 80 questions. There will be directly or indirectly questions from, I mean say, today's session. I am pretty much sure. So once again, I wish you all the very best for tomorrow's exam. I wish you all the luck, all the luck. And I suggest only one thing. You just stay calm and cool. And try to avoid such negativity that is bothering you at this time. Just try to avoid that negativity. When you enter the, exam hall, remember one thing. Just go like a doctor and come out as a doctor. My prayers are always with you. So take care. God bless you all. Bye-bye.